Should I watch through the whole video slightly, like just click around and kind of see what's happening?
Oh yeah, you can do that if you want. I mean, we did a lot of multiplication, I think, right?
Yeah, I think so.
I showed you it with squares on a grid.
Oh yeah.
So what that came from was doing prefix trees.
Okay,
Look
prefix
at my
tree.
stream, it should be up now, and look at what I highlighted.
Okay. Okay, so starting from with prefix, you can like make the tree when going from left to right. You don't just have to like read everything, then make a tree from there, like I was trying to do.
Yes. So I thought the first thing we could do is try going the other direction. So I just made a tree, and then you can try to write it out. Does that make sense? Using parentheses and prefix.
Okay.
So this one in the middle here, I'll put it bottom right. I'll send you a screenshot of it. I don't know if that's useful, but I am do it.
Okay.
Do you want like
Okay.
a really
Tree.
small one to start with? Actually, I can make another one. Like, okay, here. I made another smaller one. Try this one first.
Okay.
Hi, Max.
Okay, so I need to like stream desktop thing. Yeah. Which button? This one. Which thing? This one. YouTube quality degraded. Okay, so what's in the tree and how do I do it? That's what I need to do.
I can do a smaller one if you want to start with.
I don't know. I'm gonna
So I'll
try.
do one more.
Okay.
Okay, there we go.
Okay, so this is prefix
Yep.
tree.
Make a prefix tree that uses parentheses
I'll write
to
it out, I
show
guess.
groups.
Okay.
Like this thing we worked on yesterday. You made this into a tree, the thing that's highlighted? Or not yesterday, day before yesterday?
Mhm. I made that into a tree. Yeah. Okay. Now make this into a text. Okay, I think I wrote it out, unless I'm like forgetting something.
Okay, oh, I didn't open your... Pop out. You didn't do any parentheses. So grouping.
Uh, uh, right now I'm not sure where I do a parentheses.
Okay, do
Okay.
you remember this?
Hmm.
The parentheses can show when there's a parent and there are children. What you do is you group together the parent with all of its children.
Okay, so you group
And then when one
parent.
of its children is also a parent, then you get another parentheses to group it with its own children.
Oh, okay. So and then no, this goes all the way out. Ah, and then this is off.
Are you
All
done?
right. Yeah, I think so. Okay.
Okay,
So what you do first is
you're gonna check it? Okay.
to take away one, and then it's just 2, 3, 1. Then you add those together.
Yeah, so one of the ways you can check your work is you can count up how many parent nodes are there in the original tree.
So it's only one parent, or only two parents, and everything else is a leaf.
Yes. Yep, so you count up the parents, or in other words, the non-leaves, and that is the number of parentheses you should have, the number of pairs of parentheses. One open parenthesis and one closed parenthesis. So yours matches correctly for that, and it looks good to me. So you can do next tree up here on the top left.
Next tree up here. Oh, okay. So that okay, so we can start out with a minus, then it becomes a 3, and then, okay, this is a plus and it's going to have children, so that's going to be in a parentheses. I guess I'll also start with the parentheses here. Like, this is the parent of everything, so everything goes under it, the minus. Okay.
Oh, okay, here's a tip. When you write an open parenthesis, write the close parenthesis immediately, and then start writing in the middle. That way you don't lose it or anything.
Okay, now write an open parentheses, close it immediately, and start writing in the middle. So I do it like this, kind of,
Yep.
and then I can like write, and then,
Yep.
oh wait, so that also would mean I want to do it like this as well, and then I like start writing.
Yep, now you have all your close parentheses. You can see where the groups are. And then you can decide, am I writing inside this group or outside it?
Yeah, so you don't like forget about it at all, and you can like see what's happening better.
Yeah, also, suppose that there were a few more numbers. There's like a 4 and 11 and 1 and 7, right? And then we had... What you could do, that I think would make it easier to keep track of, is you could write the entire group for the minus.
Entire group.
At the beginning. So I'll write that. So what you do, you could go put the parentheses, right? And then put the minus. And then the things that go in the minus are 3, a group with a plus in it, 4, 11, 1, 7. And then you go back and you fill in the groups you didn't do yet. But you could get the whole beginning done at the beginning if that's easier. Sometimes it'll be easier. Does that make sense?
I don't think I followed, but I don't think I followed.
Okay, so you know at the beginning that you're going to have parentheses, minus, and every child of the minus, right?
Okay, in parentheses is going to be the minus and every child. Oh, and then, okay, and then I put this parent. Okay, so I think I understand now. Here's a parent, which is a child. Wait, okay, this plus is a parent and also a child of the original minus. So I can put that in parentheses, but it's also the second thing I do. So it should be like second.
You have your choice of the order. There isn't like a better order. You can go into depth first, or you can go into breadth first. So you can go down or sideways first. It's your choice about what's convenient. How you keep it organized or keep track.
I think I like sideways.
In this particular case where I just added these 4 numbers, sideways seems pretty good. You can just get them over with at the beginning and not have to go back for them.
Okay, so if you're going from left to right, then it's like we start with minus, and then we do a 3, and then, oh, there's a plus, so we put that in the thing, and then also there's everything else up here, so we like put it in, and then we can start doing the plus. But you could also just like start doing the plus, and like blah blah blah, and then like, oh, also now there's other numbers to do. I just did the depths now for. So this would be like a way of doing depth first.
Yep, it's called depth first or breadth. Breadth being width. Sideways.
Okay, so alright, there's only actually 3 and plus.
So I will get rid of that now, and you can do the actual tree. It shouldn't actually have more numbers there because it's a minus, and minus should only have 2 children. But
alright, I think we maybe talked about minus and multiple children. I forget though.
Yeah, you could define minus to use multiple children. You could just say that you take the first one and it's positive, and then you subtract all the other ones, and then you have a way of doing it. You could do the same thing with division. You could say if it has many children, you just take the first one, and then you divide by the second one, and then you divide by the third one, and then you divide by the fourth one, and so on. So it'd actually be reasonable. You could do them with multiple children.
Yeah, so the way that could work is like, okay, this tree and format down. Okay, if this was minus like 5, 8, okay, you could be like, okay, we start with the 5, and then we take away 8, and then we get a result, and then we take away 45, and then we get the final answer. And you can like add a bunch of children,
minus
whatever.
28. Yeah, usually you don't want to just like subtract a ton of things. If you want to combine a bunch of numbers, you can add up a bunch of numbers, some of which are negative, would be more standard.
Add up a bunch of numbers.
You can use addition and then make some of the numbers negative. So you can
okay,
do...
so if we wanted to do 5 minus 845, then what we could do is like
Here, did you see what I just drew?
Plus yes.
Right, so you can do this. Make sense?
Yeah.
And this is more flexible because you can have multiple positive numbers. You can also like add 2 and add 22, right?
Mm-hmm.
If you're doing it with a minus, then every single number after the first one would have to be negative, or you'd have to put in negative numbers and subtract the negatives in order to add, which is just kind of confusing to have double negatives. It's easier if you only have positives and single negatives. It's less confusing.
So if you wanted to use this to subtract things from 5, then you could like figure out like, okay, the first 5 is like the starting thing, then we subtract 8 and then 45. Or you could just do it so it's like a plus, and then it's like, okay, we start with 5, and then we add a negative 8, and we add a negative 45, and that like it's the same result.
Yep.
And then also more flexible. You can add whatever you want.
Yes.
Okay.
Okay, so try to turn this one to writing.
Alright, so where are we at? We're at the plus. Okay, what does plus have? 2, and then child plus, and then 2. Okay. Then what does this plus have? Has 1 and 10. Okay. So, how many parents is there? 1, 2, 3. 1, 2, 3. I can see it like, I can like look at the operator, look to the left, and see like, okay, this like started parentheses. Then I can look at the operator, look to the left, started parentheses, then ended a parentheses, ended.
Okay, so let me check what you did. You're subtracting 3, or you're having 3, and then you're subtracting that group. The group is a plus with a 2, a plus, and a 2, and then plus has 1 and 10. Yep, looks good.
You can make it.
Alright, so now here is the big one.
Okay, I'm just gonna try to focus on just writing it out. Okay, so what do we start with? This. Okay, then what do we get? A plus. Okay, then after the plus, what do we get? 4 and a 3, and then plus. And then it ends there. Okay, then what's the first plus? Oh yeah, so here I can like kind of understand doing depth now. Like you kind of never lose your place or something. You can like just, okay. I see
It's
the
just a
purpose.
different order to go through the tree. So there's basically 2 orders. So I'll draw the depth first one. We're gonna stick to the left. And then when we get to the bottom, finally, then we'll start backtracking. So we're gonna get this, then we're gonna come back up, and we're gonna keep sticking to the left. We're gonna come back up, and then we're gonna go back up again and get this one. And you get stuff on the same level before going up more. Like you don't go up until there's nothing left to do, and you stick to the most left thing that's available.
Mhm.
However, there would be breadth first. We'd start at the beginning, and we go here, and we go all the way across. And then we could go here and go all the way across. Go here and go all the way across. We could do that. There are other possible orderings as well, but those are two of the ways you can go through a tree.
Mhm.
So there's also a hybrid technique, which I think is actually pretty decent.
Yeah.
But I don't want to erase this right now, and I only have two colors. So I'll tell you the hybrid later.
Okay.
I'll
Okay,
write
that
in
wasn't.
like hybrid.
I don't think that was how I was gonna plan to do breath. I was gonna like.
You can definitely do something else. It doesn't have to be exactly this way, but this is one of the meanings of breadth. First, is you're just going the entire way across before you do the entire level before you go to the next depth. Everything on level 1 is done before everything on level 2 is done before everything on level 3, etc.
Oh, hey, curi bot made the notification for your
Oh, yep,
video.
it does that.
Okay, so uh oh no, now I can't really see the tree too well.
Oh, well, I sent you the image in IMs. You want to use
Uh,
that?
yeah, I can. I need
That way
to.
I'll leave the paths up for a while in case you want to think about them while you're going.
Okay.
But yeah, some of those numbers are a bit covered.
Okay, so I did the 3, and then I did the plus. Okay, now we're going to the plus. Okay, so what do we have? We have a minus, which is also gonna be a parent. Okay, minus, which is a parent, and then like draw that. Okay, then what do we have? A division, which is a parent. Okay, then we have 3. Okay, now let's get to the minus. So like the thing I'm doing that's not breadth is I'm like immediately going to the minus instead of like finishing up like the plus on the right of your image. So I'm like going to the minus instead of like doing the plus.
Okay.
Okay, so now it's at the minus 5 and 2. Okay, then what's at the division? Okay, 12, then plus. Okay, what are we doing in the plus? A 1 and a 2. Okay, now that should be good there. Okay, now there's a 4, the 3. Now we're at the plus here. Like, what's this plus? A 2 and a 3. Okay, I'm pretty sure I completed it. I'm just trying to look at the parentheses now.
Minor
Okay.
thing, you want to have a space after your operators before the numbers. That's how
All
you count.
right. Yeah. Uh, that was not consistent enough. I noticed I like didn't do it a few times, and I was like, I want a space there. But then like there were 2
Yeah,
operators
especially with
here.
the minus, it looks like a negative number.
Yeah. It might be a negative number if it has that. But okay. Okay, so operator parentheses, operator parentheses, operator parentheses. Okay, then this one is closed. Okay, then there's a new parentheses because it's a child of this plus. Okay, division, and operator. Okay, operator. Okay, closed, division closed, and then plus is closed, I think. Wait, what is this one? Oh, right, this is because of the parentheses. So this is the plus, then the parentheses, then this is the plus closed. Okay, Then it's just 4 and a 3 for the original thing. And then a plus with the parentheses for itself. Then plus ended and times ended. Okay.
It looks okay to me. Send me that in text. Paste it in Discord somewhere.
Okay.
Okay, I'm gonna use Atom for this. I don't know exactly how it works, but it shouldn't be too hard to figure out. Okay, look at this. It shows you parentheses matching. You put your cursor next to a parentheses. Do you see the little blue things?
Whoa. Yeah.
Yeah. Parentheses matching is a nice text editor feature. Okay, now here's another thing. Okay, I type a left parentheses and it automatically types a right parentheses next to it for me.
Oh, it did that sometimes, and I wasn't sure why it was like doing that when I typed things, but that makes sense now.
Yeah, it's more useful than it's not useful on average.
Yeah.
Especially for coders who are one of the use cases for this. Okay, and then another thing is you can do tab indentation. Oh, it didn't. Okay. I should tab these as well. Okay.
Shit, yeah. Okay, I don't know how the Atom tab indentation works, but for this you have to, if you want to do something like that,
I did it
okay,
pretty
so
manually. I just
just,
mostly I just controlled it myself. But with Atom,
you have to,
so if you return something, it'll go to the tabbing of the previous line. You can keep getting the same level. You don't have to type all of the tabs manually.
yeah,
There
you'd
might be
have to do
better
the,
settings
you
that
have
are
to do the
available.
tabs manually on these, and it's a pretty long tab, I think.
Yeah. So, can you read this version?
Okay, you can like read it as a tree. We start at X, then there's a plus, and okay,
Let me try
X.
this. There are columns that help you figure out what the fuck goes together.
Yeah, I
The things
noticed.
in that column are the children of the X. And then
Mhm.
I will attempt to draw another column. And those are the children of that plus, and then oh, this 3 is also a child of that plus? Is that true? I'm gonna look at the tree. So we're dealing with the first plus, and its children are a minus, a divide, and a 3. Oh, this I have something in the wrong place. That's why I was confused. Okay. This plus should be inward more because it's actually a child of the divide. Fixed it. Okay, and then we have the children of the division are right here, and the children of the plus here. Children of that other plus are right here. So this helps you see what you're doing more.
Yeah. Having it with like the lines and the
I didn't split up
indentation.
the -5 too onto its own lines, but whatever. You can make choices about how much to split things up. Like, if you just have a small thing, you can leave it all in its own line. It's just, you really want to do what's visually the most useful for you instead of like splitting everything up is actually better. Does that make sense?
Hmm. I don't know what you just said or what that means, or I
Okay.
like didn't
So
get
like,
it.
you see how I left the minus, the 5, and the 2 on the same line?
Mhm.
Okay, so you could split everything up. So every single thing is on its own line.
Okay.
But it's
Oh.
actually uglier. So like, let me make it actually nicer. You can keep small amounts of simple stuff together on the same line, and it's actually easier to read.
Small amounts of simple stuff on the same line, and it's fine to read.
Yeah.
Okay. And then you could do
See,
the
I think it
tab
is now
stuff if it's
easier to
like.
read now than before.
Mhm.
Like, I think -5 2 is simple enough that we don't need to break it up at all.
Yeah. Uh. Okay. So how would it be broken up normally? It would be like. Okay.
Well,
So
we
right now it's
could,
a child of.
take the 5 and then tab it forward and then put the 2 on the same line as the 5. So these are children of the minus. Over and then down.
Oh yeah, so it like tabs it, so it's like the children. Yeah.
Okay. But if you're more moderate with your tabbing, I think it's easier to read. Like tab some of the stuff, but not all of it.
So if you need to be like really specific or something, then like maybe tabbing everything is important. But it would like make it harder to read. And if you're
Okay.
like casually reading it, then maybe you'd miss more stuff.
Okay,
But
think
if
about
you're
it
like,
this way. So for your text here, it's like a straight line. And if you tab
yeah,
everything, it's like a straight line downwards. Or maybe it's a diagonal line downwards.
yeah,
But the optimal shape is if you make it into more of a square. So you're using both dimensions. If you're using left to right and up to down, that's generally better than if you're only using one or the other.
I think that makes sense.
Yeah, so you split the stuff up, so some stuff is vertical and some stuff is sideways instead of all one. Because when it's all the same way, it sort of gets cluttered together. So switching back and forth helps clarify things, spread them out a little. So yeah, Atom has a variety of features, and this is what I was doing in plain text mode. But now, no Lisp mode?
Yep, added in off topic.
Let's see what closure does. Okay, so closure auto-indented for me properly. So it's handling the indentation for me without me having to. I didn't type any of those tabs and it knew where to put them. We can probably get a common Lisp thing. What scheme? No. You can probably download
Zertovi added us in Discord. About something Lisp I don't quite understand. Okay.
Oh, Max said something. I see.
Zertovi Max K.
Yeah. Atom is not my standard text editor. I usually use TextMate, which is very old and has issues, but I'm used to it. So I'm not as familiar with Atom stuff, but there should be some relatively simple way to download some packages. Like four packages, 0 out of 8. I don't understand. How do I make them appear or something? Are they themes? No, themes are visual.
Oh wait, this is showing installed packages maybe? Was that what you were looking at?
Well, I'm trying to look at, it says core packages 0 out of, I just want to find a Lisp related package. I'll have to Google it.
Okay, so I think those are like the packages you have on your PC. What about install at the bottom of Atom selection list?
Oh wait, the core packages are showing now. Okay. Filter packages, name Lisp. Oh, 0 of the core packages have Lisp in them. I get it. What scheme? Okay, so yeah, we just have to search Atom Lisp package.
There's an install button which I feel like might be relevant in Atom.
Yeah, you can get a Lisp package, but it looks like if you just pick closure, which is a type of Lisp that I'm not very familiar with, it was doing a good enough job with the indentation. And that one was installed by default. But yeah, you can apparently get Atom Slime. So if I type in slime, is it going to show up? No. Okay, so you just have to get it from the internet or something?
I'm not very familiar with programming languages at all.
Yeah, the point here is just the they know the structure. Like Lisp uses parentheses, so they know how to tab things. Like I type +1 +1 2, and then when I hit enter, it tabbed once for me because it knew that we're in the middle of parentheses, so it should tab once. And then I hit -2, and now I hit enter, and it tabbed for me. I didn't have to type that tab. because it knows that there are currently 2 open parentheses that haven't been closed yet. I'm going to type a 3 here. Then I'm going to go after the parenthesis. And now it's going to know there's exactly 1 open parenthesis. So when I hit enter, it will go back 1. Wait, it fucking didn't know. Alright, well that's not very good. It ought to know. It should have gone here. It should know that we closed the parentheses, so it needs to back up.
Okay.
It can be auto-detected. It's possible to auto-detect how many parentheses are currently open.
Well, it's possible to auto-detect how many parentheses are currently open. So,
right, you just count up the number of open parentheses and the number of closed parentheses. And you can be like, well, there were 2 open and 1 closed, so we should be at 1 indentation level now.
So 2 open, 1 closed. That's like 2 minus 1, which means 1 indentation. So, like at 2, we're at just 2 minus 0. Or, okay, if we look at the second line, then right now we're at 2 minus 0. So we want 2 levels of indentation. When we get to the third line, oh wait, well I guess it like measures the last line, I think. So it's like measuring the last line for how many you'll need in the current line. So like at 2, we measure the last line, 1 open indentation, which means 1 tab. And then at the third line, it's like, you see that it's like 2 open indentations, I mean, 2 open parentheses. So you have 1, or 2 open parentheses, 2 indentations. Then on the fourth line, it's 2 open, 1 closed, so 1 indentation. Okay, I think I get it now.
Yeah, so this wasn't perfect, but it definitely helped. It makes it easier to type them in. So you can just open Atom and pick closure for the language. And
wait, so what's the bad thing that happened with Atom?
It didn't know to unindent after I had a closed parenthesis. No, I wasn't going to get VS Code. I was just looking up what it was. I'm familiar with Visual Studio. I just didn't know the abbreviation. I haven't used it for a really long time, though. Let's just see really quickly what TextMate does to compare. Okay, plain text mode doesn't even know about tabbing. Here we go, Lisp. Right, and then I'm going to close a parenthesis and type something. And it doesn't fucking know either. Okay, yeah, TextMate is doing the same thing, where it doesn't know about unindenting very smartly. You could try a different one, like... Wait, that one didn't even indent. So if I'm on Lisp when I hit enter there, it indents, but Scheme does not. Yeah, some of these language packages I have here are very old and not great, I think. Closure even on the list? Nope.
Damn. So there's like...
I haven't actually done Lisp coding for a long time, so I haven't looked into this.
There's a lot of languages.
Oh, yeah. No, there's a lot more than that. That's just like a subset of default installed one.
Yeah. So I guess like part of the reason there's a lot of languages is you might have like a base language, like Lisp or something. Then you could have forks, I think are the name for them, where it has like other features or like changes by someone.
Yes, that is correct, and Lisp has definitely been forked. Or, okay, so a fork is where you take someone's code base and then you start from there and you edit it. But what's happened to Lisp more than that is like fresh rewrites where they just start over and they make like a very similar thing with that's also a Lisp, but they write their own compiler from scratch. I think that's
don't know
more
what it.
common.
Okay, so it's like they're kind of inspired by Lisp and they're thinking about Lisp while they're writing new code, but it's still
Yeah,
like
and they often
new.
make the syntax the same. So like sometimes they're compatible enough you could just take a program from one language and use it in the other language. They copied everything. But they still might have written their code from scratch to implement their programming. Anyway, yeah, Atom is good enough. It will make your parentheses easier for you by showing parentheses matching. But it's funny, if you highlight the parenthesis, it doesn't show the matching. You just have to put your cursor before or after.
Okay, so how did you make the atom do a thing?
I selected
haven't
the
used.
language as closure, and that's all I did to configure it.
Okay, so it's a language at the bottom. Now, how do I make atom do text? Okay. Welcome guide. Version. Collaborate. Choosing. Customize.
Like file, new file. Is that what you
Oh,
need?
maybe. Yeah. That's exactly what I needed.
So yeah, Atom will be an upgrade over Notepad.
Okay, then it has plain text and closure.
It's a J. There it is. It showed up.
Closure. Huh. Right.
This scheme one just must be like a minimal syntax highlighting thing that they just didn't implement all the features.
Syntax. Oh, hey, it has colors. Why is there colors? Oh, hey, it shows the parentheses. Wait, so what is your problem with the parentheses not showing up?
Oh, okay. So like if you put your cursor before or after, it tells you where it matches, right?
Yeah.
But if you highlight it, it doesn't show you anymore. It doesn't show you the matching one. I just thought that was dumb.
So if you
See?
like were to do this,
Well, if you highlight a single parenthesis.
okay, single
So it's very obvious which
parenthesis.
one you want to know the match of, and it doesn't tell you. So they could
Yeah.
do a better job.
Okay.
TextMate has a little bit of a different highlighting. So when I press right arrow here, like I move my cursor past it, then it does like a big highlight.
So when you press right arrow, does a big highlight? Oh no, I clicked mini player.
Oh yeah, if I already indented the previous line, it'll stay indented. Even in plain text mode, it does that. Atom does that too. Replying to Max. Okay, anyways. Okay, so you figured out this tree and you converted it into text. So let's go the other... Oh, hybrid, right, hybrid. Okay, so my hybrid method goes like this. You take something, and then you got
Wait,
all
can
of
I?
its children.
Oh shit, I paused your stream, I think. I need to refresh to get to the live. Okay. Start at X, take all its children. Yeah.
Yep, and then you take the one on the left, and you find all of its children. And then you take the one on the left, and you find all of its children. And then you go back, and you keep taking the leftmost thing you haven't explored yet. So in that case, it's this division. So I will switch colors now, and we'll go here, and then we'll go here, and then we'll go all the way back to this one. I think this is what you did, or very similar.
Yeah. Okay. I
So
think I like the hybrid one.
Yeah, so you get all the children of the current node, and then you look at all the things that have to be explored more, and you just pick the left one and you do it again. And you find all of its children, and then you repeat.
Okay, so you start at x, find all of x's children, then we go to plus, find all of plus children, then minus, find minus children, then back, division, then 3 doesn't have any children, okay, then the plus, that's 1, 2, okay,
Okay.
then we go back to x, and then plus, 3, 4.
Okay, so I will now take Adam, and I will write up a new tree, and you're going to convert it into an actual tree from text.
Okay, new tree, actual tree.
Okay, try that.
One thing I'm confused about is why there's an enter and indentation on the 5 and 6 at the plus.
No particular reason. Doesn't matter. You
Okay.
should be able to deal with it anyways. But there's no great reason for that. I just hit enter and type some more stuff. And the indentation is a guideline to help you see what's going on, but it doesn't actually control what's going on. The parentheses control it. Does that make sense?
Okay, so you could like kind of put this in any order you wanted. You could literally have every character just be in a straight fucking column down, but you could
Yes.
like still read it and figure it out.
Yes, the white space is not fundamentally important. It's just to make it nicer.
It might be important though when it comes to like negatives, if you want to know if it's a negative number or not.
Well, yes. So everywhere there's white space, you could not delete the white space. Like, for example, here, if I deleted this white space, it would change 4 and 2 into 42. It'd be bad.
Yeah.
But everywhere there's white space, you could change it to any other amount of white space. Like, one space could be 3 spaces or 5 new lines or whatever. And it wouldn't affect it. Because the pattern is parent, any white space, child. This is the pattern. You know? We can even put the white space after the parentheses as well. Like parentheses, any white space, parent, any white space, child, any white space, child, any white space, child, any white space, and then finally any white space and close parentheses. Make sense?
I don't quite understand this new thing exactly, but I think I understand.
It doesn't matter
Like
how much white space is in this places. Let's say any white space. It could be one space,
okay.
or 2 spaces, or an enter, or a tab, or whatever. Doesn't matter.
So it's like as long as you know that they're not the exact same thing, it could be fine. Like you
Yep.
could have
And with the
negative white
parentheses, you
space
don't
and
even
have the
need one
numbers
space.
overlap.
What?
If you had negative white space and had the numbers overlap, but you somehow still knew what all the numbers were and what they were connected to and whatever, then it
Oh,
would still be fine.
yeah, I guess, hypothetically. Yeah, so white
Okay.
space before and after parentheses is generally unnecessary and skipped. And then between things, you normally either have one space or one new line and then maybe some tabs. Okay, so this one you can try to make a tree from.
Yeah, so what's the child of plus? Plus. I guess that's the rightmost child is a plus.
Finish replying.
Oh no. Alright, that's the tree. It's a text tree. Okay, what's in plus? 1, 1, 2. Okay, that tree is good. And then what's next? Okay, it's gonna be plus. And it's gonna have a 1. And then it's also gonna have a minus, which is gonna have a 2, 3. So that would be minus. Oh no. Okay, minus plus 1 minus 3 and plus plus. And then we also get 1, 3. Okay, so that's that one. And then
Hold
what
on.
is it? Oh.
Why don't you look at that again?
Okay, so full screen. Okay, so what is there? There's the, okay, I did the minus, and then that's the 2 and the 3. Okay, and then I did, okay, so what's after the minus? It is a plus, which is a sibling of the minus. Yeah?
Yeah.
Okay, and this is the original. Again, the sibling of minus, it's a child of this plus. Okay, so now we look at second layer plus. In the tree, mine is 1 first, then a 3. Okay, what is it in there? I think it's a 1. Oh, there's a close parentheses there.
Yep.
Okay, so if that's a closed parentheses, then it means we back up the 3 by 1. Okay, is that right? Yeah, I think so.
Yep, the plus only had one child. One here.
Huh. Yeah, I noticed that it had 1 child originally, and I was like, oh, that makes sense. And then I saw the 3, and I was like, oh, no, wait, it has 2 children. But I was still wrong. Or, I was wrong. Okay, then what's this division? It's a child of the original plus. Division. Okay.
Yep, you can count the open and close parentheses, or if you use atom, and I put, so you were wondering about this division. So if I put my mouse here, or my cursor, it shows me that this is the previous closed parentheses. So we know that that is closed, and then you can see that this is closed. You can count them too. You can be like 1, 2, 3, 4, 5 open, and 1, 2, 3, 4 closed. So one of them is still open, the first one. That's it.
So if we're, wait, I'm kind of, okay, if we have 2.
At this point, there's 5 open, 4 closed. So there's got to be one that's still open.
If everything is, okay. I don't think I'm quite understanding, but I feel like I understand something.
Yeah,
Like,
you're doing okay. You have it in the right place. I'm just saying you can count to double check.
okay, count the parentheses. So if we have 2 open parentheses and 0 closed, that would mean something.
That would mean you're at level 2, which is... So you can actually know where you should be in the tree. So like, we can call this level 0, 1, 3. Layers.
Mm-hmm.
Does that make sense? you can
Okay,
actually
so
figure out the
1,
number of open
2,
parentheses.
3. Mm-hmm.
Well, okay, so I should label it differently. So if you have, we label like this, it matches the number of open parentheses. So at the beginning,
Okay,
we open
so
one parentheses, and then the plus. Oh, never. Okay, never mind. So it's similar to that, but it's different. So the number of open parentheses tells you what level you should be.
mm-hmm.
But it
Okay,
depends
so
if you're the first thing or the later thing. So if we have one set of parentheses, so like this, then we're gonna have levels 1 and 2, right? The tree will have 2 levels to it for this.
yeah, there's gonna be the plus, and then there's gonna be the 1 and the 2. Okay.
Yeah. So if you have one parenthesis, you got 1 or 2 layers. The first thing in it is going to be at level 1, and the other things are going to be at level 2. Make sense?
Yeah.
Because it's parent and child. Right, and then if we add in another parentheses, where are these things going to be?
Okay, that... I guess. So the plus is going to be on level 2, and then the childs are going to be on the 3rd level. So...
Yep, so
the 1
every parenthesis,
and the 2s are going to be on the 2nd level.
so basically every parenthesis is adding another level to how tall your tree is. Does that make sense?
Mm, I think so. So we can start with like, this is the first parenthesis, and then he has all of these guys inside of him, which means that it's the... Okay, first
When we
parenthesis,
have
then we have the
this one
children.
here, we have 2 open parentheses. So now the stuff is going to be on level 2 or 3.
Okay.
If we had 7 open parentheses, then we would be on level 7 or 8, depending whether it's a parent or...
So depending on whether it's a parent or a child, you'd either be on like equal or +1 levels of how many
The
open
number of
parentheses there
parentheses
is.
tells you what level the parent is on, and then the child is 1 lower.
Oh, one confusion I think I was having up until now is like what open and closed parentheses mean. I think like open
Oh, left and
parentheses
right
is just
parentheses?
like uh okay, so that's not
The one I have highlighted here is an open parentheses or a left parentheses. It
yes.
starts a group, whereas a right or end or close parentheses closes or ends a group.
Mm-hmm.
It says this part is finished. It's completing the grouping. So yeah,
Okay.
one type starts a group and one type ends a group.
Wait. So with no parentheses, would you still just be on layer 1?
No parentheses?
Yeah.
Um, it would depend on the rule system you're using. If you don't have
Mm-hmm.
parentheses to tell you where stuff goes in the tree, then you need a system of rules that tells you where stuff goes. So the rules we were using a couple days ago let you write like a very long, complicated line and get a big tree with no parentheses. You could get many levels and write it all on one line. Because the rules were enabled that. It made it possible to have as many parents and children as you wanted. Nest them. You know what nesting is?
No, I felt like I did. Not until you asked it. Now I don't think I know
It
what it
means
is.
putting something inside of something else.
Okay, putting something inside of something else. So these are nested in the plus.
Yes.
Okay, and everything's nested in this plus.
Yep. So it's very visible with parentheses, like these are the inner parentheses which are nested inside the outer parentheses.
Okay. Wait, did I have the atom? Yeah. Oh, I have parentheses. Okay, so this is 3 open, which would mean that this is on the 3rd layer, and then these guys are on
Can
the
you make your
4th
font
layer.
size bigger in Atom?
Uh,
Yeah, that's better.
Okay. Yeah. So this guy's at the 3rd level, and then these guys, because they're the children of him, would be at the 4th level. Yeah. And then we get closed ones, so this is at the 2nd level, then these are at the 3rd level, then we open again, so this was 2nd, so this would be 3rd level, 4th level, then we triple close. Okay, so this is at 3rd level, so this would be at the 2nd level, I think. Okay, I'm kind of losing track. But when I knew what was happening, I was keeping track.
Yeah. That's fine.
Okay.
Okay, so you want to finish this up?
Yeah. So now where
You got to, you did divide and 4. Those were the last things you wrote?
Hmm. I think that's the tree.
Yep, looks good. Alright, great. So, let's go back to broad concepts for a second. So, most people don't know much about trees. However, people use trees anyways. Whether they know they're using trees or not, they come up pretty often. Does that make sense as a broad thing that could be the case?
Yeah, that definitely seems like something that could be the case. Like maybe they think about like General Motors, and then they have maybe a tree concept like, okay, General Motors, they make cars. So you can have it like General Motors, cars. And then maybe they also make a vacuum or something. So you could have like General Motors, cars, vacuums.
Right. You could have General Motors as the parent, and then all their different product categories are the children. And then in each product category, you could have different products, like specific types of cars.
Okay. Like your
Yep.
GM, and then you can have like sports, or no, would be cars. Then it can be like sports, like SUV sub.
V, not B.
SUV. Yeah.
I thought you said V, and then you typed a V.
Yeah, like try to type
They are next to each
SUV.
other.
V. Yeah, so like cars, sports SUV, like sedan, whatever. This one didn't have capital. And then maybe they also make like vacuums. And then I don't know. But yeah, this definitely seems like something people could do.
Yeah, that's not how you spell vacuum, FYI. I checked. I didn't think it
Oh,
was.
that was a
There's
W.
one
Oh,
C and two
goddamn.
U's.
Yeah, I was gonna say it was a W, but that's also a letter. I guess the letter W is called that because it looks like two U's.
Yeah, kind of. It looks more like two V's, really. Double V. It's pointy.
Yeah, it is very pointy.
Okay, so I have 3 broad categories that I came up with for how stuff works that you can organize things. So, list. The rule is every node has one parent and one child.
Mm.
Tree. And max.
Okay, so like this could be like list, and then like
Yeah, so I made up these three categories. I think they're pretty useful, so you can see when something's a tree as opposed to something simpler or something more complicated.
This you could also like kind of go to the side or whatever if you wanted to. Could like go like this would still be like
I'm not
if
familiar
these
with that,
headlines.
Max. If they used to be one letter and we split them, that's not something I've heard of before, but it seems plausible.
Okay. Uh. Okay. Imagining these were all had like a line connecting them, this would still be a list. Okay, and then
I guess we could also
spiderweb
have single things, no parents or children. That's another category. Have no connections.
Mhm.
We should have that one as well. So there's a fourth one.
Oh wait, what's this? Oh no. Don't attach. Circle. Wait, so I need to like go from the left first to be able to do this. Okay, if I start from the left, then it can't stop me. Circle.
Yep.
Can that be a list?
No.
Oh. Oh wait, this is like there's something about circles in business. I forget what they're called.
Okay,
You
I've
can
now
have
added a
like a
note. You're
circle of
allowed to have
life.
loops in the graph one. But in the other ones, I would not have loops. Loops are like a more advanced feature.
Okay, spiderweb graph diagram.
A list should have a first node and a last node. It should have a start and an end. Same with a tree. Well, a tree should have a start node, right? So
Yeah.
has start and end nodes. Has start. Whereas the spiderweb one doesn't have to have a specific node that's the start or the end.
Spiderweb doesn't have to have a specific start.
Whereas a tree always has a root node, and a list should have a first node and a last node, which could be the same node. But yeah. You could also have an empty list or an empty tree, so it doesn't actually have any nodes in it, but whatever.
Okay.
Oh, that's interesting that we mostly avoid writing two V's in a row, but there's the occasional word that has it. That looks too much like a W. Yeah, our language has a little bit of an old messy code base.
Mm-hmm. Messy.
That's a joke. I mean, it has a lot of one.
Okay, I still don't really understand. Okay, I think this is a
There's old
diagram.
stupid crap that is affecting our language that is not how we would design it today. We built on the old thing. That is
Diagram.
a diagram. I agree with you.
It's kind of like a spider web. I don't know what a graph is, but it doesn't feel like a graph.
Let's do a search. Well, that's not what I wanted at all. What the fuck is this?
Digraph?
Okay, here we go. You throw nodes in and knows what I'm talking about. These are some graphs. Those are good examples. Digraph stands for directed graph. It means it's directional. So that's another thing with trees and lists. Okay, so directional. Directional. So they go in the direction from the root node to the later nodes. Can be directional or not. Whereas this one doesn't necessarily have a start point, so it doesn't have to like pick which direction is forward or whatever. Does that make sense?
Okay. So
with a list or a tree, when you connect two nodes, one of them is the parent node and one is the child node.
what
That
was
means
the
there's a
parent?
direction because they're asymmetric.
Yeah.
Whereas with a graph, you can do it that way, but you could also have connections where neither one is the parent or the child. They're just connected nodes, like for whatever other reason.
Okay, so a digraph, you can just like connect nodes. Wait. I still don't think I exactly understand. Digraph.
This just allows like arbitrary freedom to do whatever you want. That's basically the category.
Okay, so with like a digraph, you could have it like if you wanted to, you could add murderers. Uh, like this, and that could maybe be a
Yeah.
digraph.
So there's some like this one that is similar. These are similar to trees, but they're not actually trees. Can you see why?
Okay.
These are directed acyclic graphs,
Uh,
DAGs, as
uh,
Max
at
mentioned.
at first, B looked like a tree, but then I found just below the 1, there's the 2 and the 3, and then they connect into a 4.
Yep.
So you
So
can't
it's
do that.
having the double parent makes it not a tree, it's just a graph.
Double parent sometimes seems nice for something. I forget what. I once had an example.
Yeah, I occasionally just draw extra arrows on my trees and I'm like, here, have an extra parent, who cares?
Oh shit! I
As
forgot
long
there
as
was
you
a
keep it
thing.
like mostly like a tree, it's usually fine. Whereas if you graphs can get like really weird, but if you do them just like this, it's not too problematic. It's still simple
Okay,
enough, similar to a tree, so it works
it's
okay.
like the always sunny graph. Is pretty fucking weird.
The worst thing about this though is that MindNode doesn't do a good job with it, or XMind. They don't like it. They're not meant for it. I don't know like a great app for making these. You can do them in MindNode or XMind with connections. So
How do you do connections again? I was trying to remember right now, but I
uh,
forgot.
I don't know.
Oh wait,
Look
you're
in all
on
the
my
menus
node.
or something.
Okay, it had to have been
It's
somewhere because
Command
I
L
found
in
it.
MindNode. So I can do Command L and I can do this, and you just get these arrow things. So I can have like an extra pointer. So you can make cycles with this if you want to as well. You can go L, oops, L, click, and L. There. Now my graph goes in a circle because the x goes to the plus, which goes to the x, which goes to the plus, which goes to the x, which goes to the plus.
Okay, I forget
Connected
how
down
to do
there, and it's
the
also a circle.
arrows. Okay.
Now we have a nice circle. I'll make a big circle.
Oh,
There. Now we have a big circle, like two.
big circle.
Anyway, circles tend to be a bad idea.
Oh, why?
They make it more complicated.
What if it's like a single circle where it's like a cycle of like a jellyfish life or whatever?
Yeah, that would be a reasonable type of thing to do. But you probably wouldn't want to do a tree for that. You'd just make like a circle diagram graph thing. Yeah, I've seen those circle graph things where they just have like this, right? And then you have
Yeah,
These are useful
generally.
and they're not too complicated, but they're not trees.
Mhm. Okay. Yeah. I saw one for jellyfish. It was fine. It doesn't really work for other animals because then they just die and nothing else happens. Well, I guess unless you do reproduction. But jellyfish can live potentially forever, I think.
Oh, okay. Yeah,
Uh,
so usually avoid circles because they tend to be complicated, and usually avoid double parents because it's more complicated, but they're not the end of the world.
mm,
Okay, so that is some context about trees, and they come up in stuff where people don't realize. So
uh,
one of the places they come up is writing. People do
right.
not realize that when they read stuff, it has a tree structure. This is true on the level of individual sentences. Grammar has a tree structure for one sentence.
I was finding it easier to think about with like paragraphs. So you could have like kind of a topic about something like uh GM, and you could be like, they make cars, and then that could be like a paragraph about something like talking about the cars, and then you could also have something
Yep.
else which is like, uh, they make vacuums, and you could have like a paragraph talking about the vacuums.
Yes, and
Why
then you
is
can
there?
have
Why?
subparagraphs for the cars section and give like more info.
Oh yeah, so you can be like sports stuff, and
Yep, and then
like.
more abstractly, you can have
Um,
section 1.
oh yeah, so like in beginning of infinity there are chapters, and you recommend like some chapters especially, I think, about like epistemology or whatever.
Uh-huh. That is true. And then you have paragraphs. And you could arrange it more because the paragraphs actually have a tree structure of how they connect to each other. But even if you don't worry about that, you still get a tree structure. And this is related to topics. The book is like the overall parent topic of like, we're going to talk about all sorts of interesting intellectual things. And then section 1, it's like, okay, this is the epistemology part, and then we have the physics part and the computation part. And then within epistemology, we can divide it up into subtopics like induction and empiricism and solipsism. And then we can take those and we can divide them up into paragraphs or subtopics or whatever, and have like Bertrand Russell's chicken argument.
Bertrand Russell's chicken argument? That sounds
Yep.
weird.
And then you
What's
take
that?
that and you can divide that up into different paragraphs that you can divide it into different parts, like the story of the chicken and the lesson of the chicken story, right? That could be two different parts. And then in the story of the
Can
chicken, you have the paragraphs, and then they have sentences and so on.
What is this chicken argument? It sounds very weird, which makes me interested. Weird,
Okay, so
random.
there's a naive, not very intelligent idea of induction, and the story is a
Hmm.
counterexample. And this story is told in The Fabric of Reality, and it is not original to David. It's from Bertrand Russell, who is a fairly famous mathematician and philosopher, who is overrated,
I remember
especially as a
there.
philosopher.
I remember you talking about something about like induction, moldy bread, and like whether it matters if the bread was like made on a certain day or like what race the baker was. I have no idea if that's relevant.
Yeah, it's a bit relevant. Okay, so the idea of induction is the more you observe the same thing, the more likely it is to happen in the future. So, like, you see the sun come
Uh,
up every day, and then you're like, oh, well, it came up like 100 days in a row. It's definitely going to come up tomorrow.
mhm,
So Bertrand Russell's story is from the perspective of a chicken on a farm. The chicken
mhm,
is like, today the farmer fed me. It was a great day. Then the next day that happens again. Then the next day that happens again. And you repeat this for like 500 days, right?
Yeah.
And the chicken's like, tomorrow, I'm so sure, I'm way more sure than I've ever been in my life, that tomorrow the farmer's just going to feed me and it's going to be another great day. And then the
Yeah.
farmer comes along and he's like, chicken dinner time.
Mm-hmm. Uh,
It's
yeah.
Juneteenth. We need to celebrate with fried chicken and watermelon.
Okay. So instead of induction, you can have reasons. Like the farmer wants the chickens to grow fat so he can kill them when they're like 2 years old or whatever.
Yeah.
So like a day before the 2 year mark where he kills them, it's like not super ultra sure that they're going to be alive. It's like very likely they're going to die because they're old enough now for good meat or whatever.
Yes, and it's the same with the sun rising. We actually, from physics, we have an understanding of what a star is, and that it's made of like all this hydrogen and helium and stuff, and it's actually burning and it's changing composition over time. And it has a limited lifespan, and it's actually going to burn up all its fuel eventually. And
And also, I feel like in the
so
South
our
Pole,
star only has 2 billion years left or whatever. I don't know the actual number, but
and if you're like in the North Pole, you can't actually be so sure it will rise. Because like maybe it's a part of the month where it's going to be like permanent night.
yes, there are also issues like that. But like
Okay, what?
we've studied our sun and we have an idea of how big it is and how much like what percentage of fuel is left, and we can be like, well, it has this many tons of fuel left and it's burning this many per year and blah blah blah. I mean, burning's probably the wrong word because it's nuclear fusion in my understanding, which I don't know a ton about, but I think what it's doing is it's taking hydrogen and then it's fusing it together into helium and occasionally heavier elements. Hydrogens have
Alright.
one proton and one neutron, and then helium has two and two. So it's like
I,
merging the atoms together, I think. Not an
yeah, there's
expert.
a cool video I watched, which was about like how it was like a kind of quick basic thing about like how elements were made after like the Big Bang or whatever. And it showed just like starting at hydrogen, and then like things combined, and then it made new elements, and then those did things and made new elements, and
Yes, and the
those did
stars are
other
very
things.
important to that process for turning hydrogen into heavier elements.
Mhm.
However, our power plants that are nuclear on Earth are a different type of nuclear. They're nuclear fission. Fusion means putting things together, and fission means splitting them apart. So the way
Yeah.
we do nuclear power is we split atoms apart and break them up, and that generates power. And you might wonder why fusing atoms together or breaking them apart can both generate power. And
There's
that would be a
something
good
about
question I
the
don't know the answer to offhand.
strong. Okay, with fission, I think it
And
has
that's
to do
because there's
with like the
different
strong
forces, right?
force.
Yeah, there's different
Fission literally
forces.
has the strong force, which is what you break apart when you do fission. It's literally just called strong force, I think.
Hmm. Oh, yeah, I kind of remember this. So when you
I
bind
remember you
things
talked
together,
to Alan.
well, this is for molecules, but when you bind
Oh,
things together,
molecules.
the bonds, you have to the bonds are made so that you have to put in you have to add energy to break the bond, right? That's what keeps it
Okay,
together, is
I have
like
to
it
add
takes energy to
energy.
break it apart.
Yeah.
Which means when you're creating it, you have to release energy, like the opposite of breaking it. Breaking it is adding energy, so creating it has to be like you take energy out, so there's missing energy. So
Mhm.
that's why bonding things together can create energy, if that makes any sense.
Bond them together. You have to like take energy from something.
You take the energy
Uh,
away, so it's missing, so then the bond is the reason they're stuck together is the energy is missing, and the energy has to be put back to get them apart.
hmm.
Kind of how it works.
Okay, next case. Okay, the sun event
Let's see what Max said.
is still red
The
giant
sun 5
explodes
billion
fast.
years is a pet peeve. People generally say 1 billion years till red giant expands. Those emit without intervention. Oh yeah, I was just talking about the natural life cycle. But I agree with you. I'm not expecting us to just die when our star dies. I mean, I assume we'll either leave or change the star. I don't know which one's going to be easier, but we can have our choice.
If you like fail leaving the solar system or whatever, then it would make sense to like fix the star. But if we can leave the solar system and find other Earths, then maybe it's not really worth it. Unless we have like so much progress, it's kind of a just like, might as well see what happens kind of thing.
We can definitely leave. Like, there's no fundamental force of physics that's going to stop us from leaving. Whereas I don't know if we can fix our star up or whatever. But if we can fix it up, it might be easier than leaving.
Oh yeah. I was thinking like we need warp drives or something to leave, but
No, we can leave the slow way with like cryostasis or whatever.
yeah. In a video game I play that's based on the Milky Way, like kind of everything within like 300 light years of Sol, like our planet or our solar system, is called
Yeah.
like the bubble, and it's all within like 300 light years. So that's like pretty fucking close.
Yeah, Sol is the star
Yeah.
or sun, not the planet. But also you can do generation ships. You don't even need stasis. You just like your great grandchildren get there, you know?
Yeah. The science fiction stuff is cool. But yeah, definitely don't need uh warp drive to like travel 50 light years. Okay. Uh,
Oh, we already know in principle Max is saying how to do star lifting to extend the life of the sun to trillions of years instead of billions. So that's a lot of extra time that we already figured out conceptually how to do, I guess.
yeah.
So we've already made a pretty good start on it, like way early. So that looks promising.
So I already have like an idea of how to do it, even though the problem is like a billion years
In the future,
out.
yeah.
Uh, okay. Wasn't it?
There are points to going to other planets, such as splitting people up has political value. Like you can have different societies, kind of like coming to America and founding the New World. That would be one of the reasons if people wanted to get away from each other.
I don't quite
But I agree,
understand
from
what
a
it meant.
resource perspective, they're all atoms. Unless you run out of atoms, you don't actually need to go to another place, basically.
Also, it's like more convenient and safe, I'd think, to be on like a planet with an atmosphere. Like if you're in a ship and then like uh, a big rock comes at you and hits you, that's like ship might die now. Oof.
Yeah,
But
yeah.
if you're on like a planet,
Yeah, there are definitely nice things about planets, and the Earth only has so much space, although we might make ourselves a lot smaller eventually.
maybe there could also be benefits to like asteroid colonies or whatever, where you like put a bunch of people on an asteroid belt that would have like a problem of asteroids colliding with each other.
You
But
can
maybe you
you
could.
could make like a very robust space station though. You could probably make it so that in a lot of ways it's better designed than a planet without being so fucking heavy.
Yeah, I'm not sure how that would work. Like the main thing
Well,
I
like you
think
have
our planet
sections
has.
to start with, you section it
Yeah,
off. But
that
yes,
would
our
make.
planet is so heavy that it can just hold gas to it without having to seal it in.
Right,
So that
that's.
has upsides and downsides.
Yeah, and then there's also like a huge
Oh
surface
yeah,
area, so like.
Max makes a good point. You can
Uh,
use all that
uh,
mass of the planet to shelter stuff by burying it, so it gets hit by way fewer cosmic rays. If you bury it deep, that's going to beat a space station unless you have like a very, very thick space station area. How much you need to bury stuff depends a lot on your error correction abilities, though.
so like if wait, I don't quite
So like
understand.
if you have nanobots always swarming around and fixing all the damage, then
Hmm.
you can have an error rate of like say 10 errors per day and the nanobots will just fix it.
Hmm.
And it's not going to matter really. As long
Yeah.
as like you design things in a way where they can tell what's an error or not, as long as there aren't too many errors, it's always clear logically what the errors are, then you can deal with quite a bit of cosmic radiation or whatever. This is very related to communications theory. So if you send signals over a lossy communication channel, such as radio waves,
Mm-hmm.
and the other person is trying to receive it and hear your message and figure out what you're saying, you can send accurate signals even if there's always errors in the waves. Like if your signal is always getting a little bit garbled, you can just keep sending accurate signals anyways. You just have to spend part of your signal to deal with error correction and make it clear. You add redundancy in a organized mathematical way to your signal so that even if there's errors, there's redundant information so they can find like this has to.
Yeah. So it would like require both people kind of having the
They have to know the system in advance, yeah.
system.
A very simple system for this is called parity checking. So suppose I'm going to send some ones and zeros, which built on ones and zeros, you can have bigger numbers, you can have letters, you can have whatever you want. So it's simpler, but it's actually adequate to send whatever you want. So we have like, we're going to send 8 ones and zeros. So this is 1, 2, 3, 4, 5, 6, 7, 8. Right. That many. So we're going to send that. Then a parity check is you just add one extra one that tells you how many ones there are, and specifically is it odd or even. So we count it up and we say there's an even number of ones, so we add a 0. But if it was an odd number of ones, we add a 1. And then when they get the message, they can look at it and they can count the number of ones and they can say, is it odd or even? And then they can look at the parity bit. And then if it's the wrong amount, then the parity bit will probably not match. And they'll be like, oh shit, there's an error here.
And if it's like the right amount, maybe it missed like the first zero and the first one. Like maybe the message could have like.
Oh yes, you could have a missing bit. And if it's a 0 that's missing, the parity bit isn't going to tell you. And you could also have 2 things that flip to the wrong thing, and then the parity bit's not going to know. The parity bit can correct 1 error or 3 errors. Or not correct, but detect. It can tell you there's something wrong if there's 1 error or 3 errors. But if there's 2 errors and you have a parity bit, it's not going to tell you. So, but there are much, much better systems than parity bits that are more complicated that can give you...
Better.
Yeah, they're far more effective, and they can tell you not just is there an error, but where is the error, which bit got screwed up. And so they can do that even if there's a high error rate, like say that 1 out of 4 of your bits is getting randomly flipped. You can actually have a system where you still send your message and it's extremely reliable and works anyways. You just have to make the messages longer and include redundancy and use the right math, and it works fine.
Okay, another thing I was thinking about when we're talking about this is
Hold on. And just I want to connect that to what I was saying earlier about nanobots and cosmic rays hitting people.
Yeah.
Right. So the idea there was even if 25% of your communication signal is broken, you can still have an error correction system where everything's fine. That's mathematically known. Like it's already been worked out. They know how to do it. So I was thinking the same thing with nanobots. If cosmic rays are hitting us all the time, like they're not going to be destroying like 25% of us per day or whatever. So there should certainly be a way to set it up so the nanobots can repair everything.
Nanobots would be sick. They would have so many uses.
Yes.
That would really help with cancer.
Yeah, I suppose so.
Okay. Oh yeah. Fabric of reality. Frog light thing. Interesting. Seems like it might apply here where like some messages might not get across, might not like get to the other person, assuming it's like a photons thing. Or like the messages are the photons.
Yep, if you're sending messages with photons, it's at long distances, it's not going to be 100% reliable. But you can communicate anyways if you use some math.
Okay. Can I ask an off-topic thing? I'm gonna ask off-topic thing.
Yeah, go ahead.
PHP. You seem to really dislike it. it's also used by a bunch of people. Why do you think it's bad? And then why do a bunch of people use it still?
Okay, did you say
Or well,
PHP
used to.
programming language?
Yes, PHP programming.
Okay,
Alright,
at
I
first I
think
thought
it's
you said
something with.
PhD, which is something
Okay,
else I don't like.
I think. Okay, PHP. And I think the reason you talked about it was because it's like bad fundamentals, I think. And like, I remember you
Yeah,
talking about
so
this in
there's a lot
programming
of better
thing.
people to ask about this because I've done very little PHP coding,
Huh.
but it is quite poorly designed, and this is broadly known and accepted by like all the competent people, or probably not all, but like most of them. And PHP is in like massive decline and has been massively dropping in popularity, and it got popular because it was convenient and it had a few killer apps, basically.
Okay, so
It
I
was
had like a few
installed on a
things
lot
which
of
were
web
really good.
servers, and people are like, oh, this seems pretty easy, I'll just use this, and blah,
Hmm.
blah, blah. It was sort of good enough to do some things, so people got value out of it, and it was there, and but it's not actually very good. Like, you can design things that are way better.
Mhm. Okay, that makes sense. So like
Yeah,
some
there.
things are just like better, but like PHP was kind of the first thing, and it had nice
It wasn't even
features.
first, it just happened to get
Uh,
popular.
uh, it had some things, and somehow it got popular, so people like kept using it.
WordPress. Okay, WordPress is one of the main reasons people use PHP.
Hmm.
I think that like Perl was scary to newbies. So that might have been part of it because Perl is older, I'm pretty sure. But Perl has too many symbols in it and like weird little shortcuts, so I think it's
Too many sheep.
like scary to beginners who don't know programming.
Hmm. So scary is much different than actually a lot harder.
Yeah, so Perl is better designed, like as its design is generally just okay, like it's fine, and but it has a bunch of like
Holy
quick
shit.
shortcuts.
Uh, okay, it's nothing. Just a fly. I got like hit in the head, and I thought it was like a piece of my hair that hit me, and then I was really surprised that I got surprised by a piece of hair hitting my forehead. But then I actually saw like a flying bug thing.
Perl looks too much like math and symbols to people and scares them off. PHP
Math and
looks a bit
symbols.
more like words.
Oh, so kind of like how I can be afraid of like uh, mathematical formulas. Uh, that can be like the same for people looking at Pro.
Yeah. And then Lisp uses more words and not as many symbols, and then people hate that one the most. And they claim that it's because it has too many parentheses. But I don't think that's the real reason.
Wait, so why do people hate Lisp?
Well, they claim it's the parentheses, but um, it's not. That's a big, complicated subject, though. But anyways, Lisp
Okay.
looks exactly like the trees we've been doing. Like, see this one I'm highlighting?
Yeah.
Yeah, that's what Lisp looks like.
Hmm.
Except usually you're not writing math all the time. You know, you're writing a lot of the pluses would be like words, and a lot of the numbers would also be words.
Yeah. I remember you saying something about Lisp being like one of the best fundamental languages for like a really big project.
Yes. Yes, so the bigger the project is, the more you want a good language instead of a convenient language. Like,
Oh yeah.
because
So
there's
like
other
if
languages that it's sort of like they give you a head start because they've got like a bunch of things built in, and you're like, oh, I don't have to make that, it's already there.
hmm.
But the bigger the project is, the less that makes a difference because you're making more stuff yourself.
So like if you had to say make uh I don't know, 1,000 lines of code for your. Okay, let's say you wanted to make a small like program, and it needs like feature one. Like uh,
Yeah,
PHP might
Max,
have feature
I
one.
know that they're wrong about the parentheses.
Oh, no. Okay, PHP might have feature one, and if you try to do it in Lisp, it might take like 1,000 lines of code or whatever to make feature one. But if you're like doing a project that is uh, how many lines of code? Let's say you're doing projects that's like 100,000 lines of code, then like making 1,000 lines of code wouldn't be much out of that project.
Yes.
But like
Yeah,
if you're
and
only
then also
making
the bigger it gets, um,
the more it needs to
the
like
bigger your project
interconnect.
is, the harder it is to organize it and make it work and like keep it from falling apart. Like
Hmm.
The bigger your project is, the harder it is to prevent it from being like a failure and like a mess.
Yeah, so like if you just have a small project, then like things can be kind of messy, but it still like works out.
Yeah.
Like you fixed a few things, and then you could like make another small project. You could like make hundreds of small projects. They don't have to work with each other. They can have like entirely different premises or whatever.
Yeah. But when you're trying to organize 100,000 things, then you need the best organizational system you can get. That's what's like a fundamentally better language.
Mhm.
But when you're writing a 10-line program, you don't need the best organizational system you can get. It doesn't matter that much.
Yeah.
Anyway, also the other thing about PHP is it's not the only language that isn't fundamentally the best. Most of them are also like the same kind of thing, just not to the same degree as PHP. Like most languages don't merit the amount of use they get. There are better ones that more people ought to learn how to use.
Mm-hmm. Yeah, and it's not too
You,
hard to learn different languages as well, right? I remember you saying that.
yeah, learning different
Like,
languages isn't hard if you know what you're doing, but
mm,
people often don't know what they're doing. And that's part of why they use bad languages is they don't understand what they're doing anyway, so having more advanced features isn't going to help them, and they don't want to think about things in like a good way, so part of what makes languages popular is when they're dumbed down to the ways that lots of people are dumb.
hmm. So like, what
For
is a
example,
way
that's what
people are
Java
done?
was designed to be.
Oh, job. So dumbed down, so it's like very easy for just like kind of anyone to do with their like default mistakes that like
Yeah.
everyone generally has.
You figure
It's
out
like
like the ways
appealing.
that most programmers are bad at thinking, and then you design your language around that instead of around how do we make a good language. And there's some real benefit in that. Like there's reasons you would want that to exist because it helps people who are bad at
Yeah.
thinking. But
I remember you talking that about that with like there's a lot of money to be made from like helping dumb people. So if you can like make a language uh for like dumb people so they can actually program, that'd be like really helpful.
yes,
But if you tried to like make a language that was like actually good and you wanted it to be used by the best people, like you wanted the Rorks of the world to use this language, then it would be like way fucking different.
the programmers who find it hard to learn new languages are not very good, in my opinion. Like if you know Ruby and you can't learn Python very fast, like there's something wrong with your ability to think and learn. That's my opinion. Like
Is it
so
like
many of the languages are so similar to each other. If you can't go from like PHP to C and then to Java and Visual Basic, like they're all pretty similar. It shouldn't be that hard.
so like one thing
If you have
that could
trouble
make
going
it
to Lisp, that's different. Like I'd still have a problem with it, but at least it's like significantly different than all the standard languages. So there's more of an excuse and a reason.
okay, so like with learning different languages, it could be easy because you're like, oh hey, in this language when I do X thing, uh it causes like Y result, and then you look at it more and it's like, oh, it's because of this reason. And then you can like go to language two and it's like, oh hey, the same thing uh happens.
Yeah. The main reason it's easy to learn new languages is just that most of them are very similar. Like
Mhm.
they use different words and they'll like change a few details and whatever, but it's pretty superficial and they're mostly pretty similar. They use a
Okay,
lot of the same concepts. There are,
that makes sense.
however, languages that are actually different, so it's more work to learn. But if you're actually like a really good programmer, you should be able to learn the weirder ones or the differenter ones too.
Good programmer, you should be able to learn weird ones. So for it to be like super fucking hard, then it would have to be like almost as if it was like a different skill from programming. It would have to be like that alien kinda.
Yeah. But even for a mediocre programmer or like yeah, a medium programmer, they ought to be able to learn just like a regular language and it shouldn't be that big a deal. Like any of the languages that's fairly normal shouldn't be a huge problem. Yeah, Ruby, Python, and JavaScript are very similar. I agree with that.
Okay. Anyway.
There are some major differences, but they don't actually matter a huge amount most of the time. But like Ruby is everything is an object. That's a major design difference that Python certainly doesn't have.
Hmm.
And I
Okay.
don't think JavaScript has it, but I'm less familiar. Pretty sure it doesn't though.
The thing Max said about like many programmers uh, not interested in writing better programs makes sense. It can be like kind of the same with Overwatch, I guess. Like you could try to learn like when you're supposed to go forwards or backwards, or you could just like kind of give up and just do things at like a platinum level.
Mm-hmm. The standard libraries for Ruby and Python, in my experience, are pretty similar. Like I'm sure there are differences, but for like the more commonly used stuff, generally, uh, they generally sort of agree on what sort of features people want and how they should work. But I think
Once it
the everything is an object and also Python's meaningful white space are some notable differences.
meaningful white space, how does that work?
So in Python, you actually have to indent things correctly, and it tells the computer how stuff works.
Okay, so like before, we were talking about like how white space for what we were doing doesn't matter, but for
Yeah, and
Python,
most
it
languages
like
work that way, but Python was like, you know what? Instead of writing close parentheses, we're just gonna make you tab everything correctly, and then we'll figure out where the close parentheses are. Anyway, Max, about everything as an object. Ruby does not have functions that are not encapsulated in objects. Python does. Python has like a length function for arrays or something. I think that's an example. Where you just write like len and then you write parenthesis and then your data type or your variable and then close parenthesis. Whereas in Ruby, like literally fucking everything is objects. So like print is an object. It's kernel.print. When you write print, it's an implied lookup in the kernel function is just like the default class, like a default context.
I don't really know what object is. I don't think it matters too much to know, but it's like some kind of thing that programming does, and in
Yeah,
Ruby,
yeah, don't worry about it.
everything is one, but in other programming languages, it's not. So I guess like if something's an object, then you have to like treat it differently than if it wasn't an object. In Ruby, it's an object, so you have to like kind of treat it differently.
In Python, all values are objects except you mentioned bools and ints, and probably strings, I would guess. So some other things. Whereas Ruby actually has like an ancestor hierarchy with like fixed num and various different numeric types. So I think Ruby's more elegant that way. Like if you're gonna go object oriented, I think you should go all the way instead of halfway. Like if you're gonna be at least 30% object oriented, you should probably be 100%, I would say.
I'm gonna be back in like 2 minutes.
Yeah, the concept of fundamental things in the interpreter is making the programmer care about compiler details and hardware details and that kind of thing, which is again something where I'd say if you're going to be a very high level language, just uh, insulate the programmer from that stuff. And if you want to deal with like lower level optimizations, let the programmer deal with it as like optional things, or they could even drop into C or whatever. But I wouldn't. If you're going to have like a 90% high level language where you're not worrying about performance, I would just make it you never have to worry about performance unless you want to. Yeah, JavaScript has weird kinks to it, quirks or whatever. You have to use like triple equals a lot instead of double equals because stuff is stupid. That's my understanding of that one. Yeah, learning like the weird quirks of languages can be like an annoying hassle, but it's not super hard if you actually care enough. I've programmed in mostly just Ruby for a long time. I don't program a huge amount. Well, that's not my priority anymore. Ruby is fine. I like it more than Python or JavaScript. It has its own, it's got some quirks too, though. It's convenient enough, and I don't do large programming projects where I'd really want to think about a better language. Oh yeah, I started Ruby when like Rails 2 came out, around then. So I started using Ruby like a bit before its big popularity spike, I think. Or on the very early end of the popularity spike. God, Rails was so much fucking better than most of its competitors at the time. Like, I used several of them, like some Cold Fusion, and you were like literally writing. What are they called? The apps that Ruby just has free scaffolding for? CRUD apps. You'd like literally just be writing all these CRUD apps by hand, and it was very stupid and tedious. And then Rails was like, we'll just give you that for free, automated. We can code generate that for you.
Wait, so what's the CRUD app? Is that just like a basic thing which like it would be
It's a
nice to just
create,
repeat?
read, update, delete web app. It's a web app where you can enter data into forms and then list out the forms. And then on everything in the list, you can click update or edit. And you can also click make new one. So it's a very standard type of website page.
Hmm.
Python has some better performance and has gotten attention from like the scientific community more, and it's got like a bunch of libraries Ruby doesn't, I think. There are other differences. Ruby came from Japan. I think that's a major problem in terms of widespread adoption because of like communication and stuff. I remember when I was doing the CRUD apps before Rails that I wrote my own ORM from scratch for one of the apps because it literally saved time to make one than to just do everything the tedious way. ORM is object relational mapping. I think that's the right term, where you make it's just a software layer between you and the database. Which, you know, pretty obviously is a good thing instead of just like writing fucking MySQL queries in the middle of your Visual Basic code or whatever. I remember doing not only did we have to drop into SQL in some of these projects, but we would go into like the database management tools and write like query plan things. I forgot what they're called. But you like write your queries in advance with wildcards and like enter them into the database, and then you call those from your code. So it's all very, very specific. And you're typing, it's the same create, read, update, delete over and over every time for every database table. It shows how like low standards even programmers have, that they'll put up with tedious stuff that the computer should be able to automate. Like most programmers aren't very good at like taking the initiative to automate things and like realizing that they should be doing that. It doesn't like click for them that whenever you do the same thing 3 times in a row, that is a sign that you should make the computer do it. I have not worked with other programmers very much. I've worked on small teams, but I've mostly worked alone. This comes up with Alright, watch this. So I hit Control S with cap locks being my control key. And then I have my screenshot to clipboard. And now I have something on my clipboard. And then I go to my blog. And then I hit one more hotkey once I put my cursor here, which is Command Control 3, but whatever.
Image uploaded.
And now we have a markdown image text, and it has uploaded that image file onto my server, and it has named it with dimensions, which actually lets my code be a bit cleverer for displaying stuff. It is very easy, and it's the kind of thing that people should automate but don't. It's not that hard once you figure out you can like brew install PNG paste or something like that. There was like literally just a library for doing all the actual hard parts, like pasting your clipboard into a file or whatever.
What's a library? Is that like things people have already figured out, so you don't really have to do it yourself?
That is an accurate description of it, but it is not a normal description. It's not getting at like the main point. The standard way of talking about a library is it is a bunch of code files that are meant for being reused, and you've packaged them together so you can send them off to other people and they can use them too. Yeah, actually my friend found PNG paste or whatever it was for me and wrote like half of the script for me, but I could have found it if I really needed to. I have another one that's really useful. It's just like very simple Apple script. Oops. I didn't show that, but here we go. Okay, this is just a reply to a random FI email. And then Apple broke the quoting because they don't understand quote levels and nesting correctly for some reason. So the attribution line is quoted. This is actually very similar to the tree stuff. They don't understand parent and child correctly. Or I assume it's not Apple that doesn't understand it. I assume it's their customers, and then they decided to pander and not even make an optional setting. But so internet, look at this. So you see this as an email? I am
looking.
Right, I just hit reply to an email.
Wait, I'm not looking. Am I looking now? Okay, I'm trying to go live. Okay, I'm at the live part.
Alright, tell me when you see hi.
Hi. Oh
Okay.
shit, I'm way more live than I was before now.
Oh yeah, stream delay gets worse over time if you don't refresh.
Alright, one thing I can do with VLC is just like put it at, not VLC, the speed controller. I can put it at 1.1 times speed maybe, and I don't really care about audio clipping, and it might make me stay more live.
Oh, yeah, I guess so. Usually I don't do that because it causes stuttering, but that could be reasonably useful.
It's not called, yeah, I misused clipping. It's like just audio stuttering.
By the way, you can watch streams in VLC and it might be useful. There's scripts that can let you do that. It's pretty easy. There's a thing called Livestreamer that hasn't been updated forever, but I could maybe show you that, although I don't know how easy it is to set up on Windows.
Hmm.
But I found sometimes when I would have stuttering on Twitch website that if I used VLC it would work better.
Hmm. Okay. Using the fast forward shortcut on live YouTube videos will make it so it stops fast forwarding when it gets to the live part. But with VLC, you can force it to just speed controller. I forget what its name is. You can just force it to stay at like 1.1 times speed, even if it's live, and it keeps like causing some small stutters. In reply to Max K.
Okay, so look at this email. They have all this stuff on the same
Email.
level. So the
All the
nesting
stuff
level,
in this.
this is like the tab indent level. Like this thing right here, this bar here is showing tab indentation basically. Does that make sense?
Yeah.
Right. So the bar on the left is the tab indent, and they're saying this is level 1, this is level 1, this is level 1. This is there happen to already be tabs in it, but whatever. All this here level 1. That is
Yeah.
actually not correct. So this is a quote. So it should look like this. Alyssa wrote, and then this is the stuff Alyssa wrote. So it's
Yeah.
just like if you write Ayn Rand wrote, and then you say Howard Rourke laughed. You know?
Yeah.
Like, it makes sense that the quote is nested and the attribution is not, because you're saying this is a child that is nested under the parent, right? This is the parent, this is the child. You
Yeah.
have
So if you have
the
like,
introducing the quote and the quote.
yeah, so if both of those were on the same level, then it would, uh, it wouldn't really work because like Ayn Rand wrote what the thing you're quoting is
Right.
like still
It would
you.
just be like this. This is what if they're on the same level, it's like this. Or if you do this, it's like the same and also makes no sense.
Yeah, it's like you're quoting someone else who messed up quotes.
Yeah. The way it was on FI is how every email client worked until Eternal September got really, really bad. It was just completely standard, including from Apple, by default. Um, People get confused because they think like that the name of the person who wrote it should be the same color as the stuff they wrote. I think that's what it is. I think they're like, I'll just match the blue author to the blue text, and that's how I'll figure out who wrote what. I think that's what people are doing. Best guess. Anyway, so it used to work completely correctly in Apple until they ruined it.
When did they ruin it?
Like 5 years ago, maybe more by now.
Huh.
But however, anyways, the point is I have a script on a hotkey, so I'm now going to press my script. This is a single hotkey press. And now my quoting is fixed.
Hmm.
So some people complain that it's so tedious to deal with Apple breaking it, but it's not that hard to fix. Yeah, I don't know why, Max. There's definitely ways they could have made it better that also would have not been broken. There was room for improvement, but they weren't looking for improvement, I think. Anyway, here's my script. I want this bigger. Where do I drag? Oh, I just drag there. Okay, here's the script that does that. It's really actually very simple. So there's a delay so that you have to let go of the hotkey because you don't want to be typing anything because the script just literally types for you. You need to like not be touching the keyboard so it can type. You have a delay, and then oh, the dash dash means comment, so we can just ignore those lines. And also the stuff in parentheses with stars, these are comments, so we ignore them. So the actual code is key code 126 using command down. So we're just literally hitting some key, and then oh, that is command up arrow. So I'll show you how it works step by step. Okay, so I start with command up arrow because that takes you to the very top. It puts your cursor at the very top left from wherever it is. Go all the way up. And then the next thing I do is I press down arrow. And then I hit delete. And then I hit down arrow. And then I hit delete again. and then it hits okay, then we hit unquote, which is a hotkey. Then we hit down arrow, and then we hit unquote. Oh, wait, did we hit right arrow? Oh, we hit option down arrow. Yeah. Anyway, it just goes through hitting a couple like arrow keys and unquote keys and delete keys, and that's all it does. Because it's literally just a predictable series of hit like 10 different keyboard keys in a row, and now you fixed it. It's always broken in exactly the same way. So it is not actually that hard to deal with this. And you can get other tools to let you do that. Like there are tools that let you just like hit a bunch of buttons and then it can play back those buttons. So you can do it that way.
Yeah.
Like you can get one of those and you don't have to know any programming at all. And you're just like record this series of buttons and then play it back on a hotkey. It's keyboard maestro. This is one of the ones that'll do it on Mac. They call them macros. You record a macro and then you can play it back. Some Razer Synapse can do that as well.
Yeah, Logitech gaming software can do that as well, and I'm guessing Corsair might be able to.
I don't know. And like Auto Hotkey can probably do it.
Yeah.
I don't know if Auto Hotkey has recording or not, but
Yeah, I don't know. Seems like a thing you can do with Auto Hotkey though, just tell it to press these buttons.
yeah. InternetRules is on Windows. That's why he's been using Xmind instead of MindNode. Okay, so what I was trying to talk about earlier was people use trees without realizing they're using trees.
Yeah.
And you can look at things in categories like nodes with no connections, nodes connected in a list, nodes connected in a tree, or nodes connected in a complicated web.
Yeah.
So I wanted to give a very simple example with grammar. So okay, can you find a parent and a child that go together in this sentence?
Okay. A parent
There's
and a
multiple
child.
answers you could give, but I tried to put in one that
Yeah.
is like really straightforward.
Okay. So, I'm pretty sure it's gonna start at I, but I also would like to try to mix things around. It's like, what if the parent was like, and then like, what could the children be? Like I? That doesn't really make sense. And like red, uh, okay, like what likes red? And then you could put like I at the end. That would seem weird. So you could do like I like red, and then that would make a lot more sense. And kind of like a tree. Okay, so starts with I. I can move tree stuff. I. And then, okay, and a tree. Oh wait, well I guess it's just I and like would be fine. Uh, for like a parent and a child.
Is like actually the child of I.
Uh, hmm. Okay, so I is talking about you. What do you want to know? What is the sentence getting across? It's like trying to say that you like red cars. Like they are good. Uh
Okay, so
what?
if you're not sure, try looking at other ones because there's you're gonna find one where you can give an answer more easily.
Okay. I read.
And Max, I used auto hotkey when I was playing Warcraft 3, specifically an RPG map, and I auto hotkeyed changing my gear around, which had to be done with mouse clicks. So I just auto-hotkeyed tons of mouse clicks to put on different gear sets, which was a bit of a hassle, but it saved time compared to doing it manually all the time.
Mm.
It was so there were elixirs that last like half an hour and they give you plus 15% spell power. So what you do is you put on all your plus spell power gear and then you use the elixir and then you switch back to your regular gear and you get a larger buff from the elixir.
Ah, that makes sense. Alright, so then one thing you could do, if you wanted to, would be like to have it so when you press the elixir, it first puts on your gear, then, well, not exactly sure how it would work. If it's like just a single hotkey that the elixir is on, you could make it so that hotkey put on all your gear, then activates the elixir, then unequips it.
Yeah, Warcraft 3 doesn't have a gear system at all. It was completely custom with a custom user interface. And the fact that they like got clickable stuff to appear on screen that you could actually drag gear around, or you couldn't actually drag it. You clicked somewhere and then you clicked something and then you clicked the destination. It was just like click the start and end points of a drag.
Was this
The
on
fact that
like
it worked at all was
T?
basically a hack.
Was this for like TCOM?
Yeah, it was for TCOC.
Okay. I read. I don't think that makes sense. Uh, cars. Also, don't really think that makes sense. Uh, do I think something else could be the parent? Could liking be a parent for I? I don't think so. Could liking be a parent for car? Uh, well, it's not, because you like red cars, not cars in general. Maybe you fucking hate cars, but it's only red cars that you're interested in. So like red car. Uh, would it like maybe you hate red, maybe you hate cars, but combined you like them. So I don't think they could really be like separated red car. I don't really think you could. Also, maybe it's only in multiples or whatever. I don't quite understand how cars work. Okay, I think this is a parent and child.
That is a reasonable claim. It is not, however, the one I was looking for. There's a clearer, easier one.
Hmm. Oh, cars that are red? Red cars?
Yeah, so if you look at red and cars, they have a strong relationship. They're strongly connected, which is something you just
Yeah.
mentioned a minute ago. So which one would be the parent and which would be the child?
Uh, okay, cars red doesn't really make sense. I'm very sure it would be red cars, but I'm trying to figure out how cars red could work.
Yeah,
Uh,
so that's English. Which one goes first in English as the adjective goes first. But for parent and child, it's a different issue. Um it's like which one is a higher level thing and which one is more of a detail thing is one way to look at it.
child. Wait, so
Or
for
like
parent, child,
generally you want to put
something.
like the more important thing is the parent.
Mm-hmm. Like more
Like when
important.
you were doing GM, like GM the whole company was the parent that went on top.
Yeah, it's like the most kind of big thing. Mm. Oh yeah, I saw David Horowitz talk about how like people of color kind of isn't really English because it like puts color at the end. Uh,
Yes, colorful people would be better English.
hmm.
Or colored people.
Yeah. He like compared it to French, and he said it would be more like French. It would be like people de color or something, like people.
Yeah, yeah.
Yeah.
Yeah, some other languages put their adjectives after their nouns a lot. Including with like an of. In English we have adjective then noun and we also do have noun of adjective, but it's less common and only done for a certain thing.
Say the last thing again.
using like a noun and then the word of and then throwing on your adjectives is like less common in English.
It's like red of car.
You get it a lot in World of Warcraft though. You have like Maul of the Bear, for example,
Oh, yeah.
instead of like Bear Maul. It's very commonly used in RPGs.
So, like, you could also have, like, Bikers of Freedom instead of Freedom Bikers.
You know why they do it in RPGs though?
Okay, I want to think. Okay, why do they do of the? Okay, so there's Bear Mall. That's not very cool. But like Mall of the Bear, that
Nope,
sounds way
not it.
cooler. Oh. Hmm. Uh. Okay, you can have a Bear Mall or
Okay,
Mall
I will give
of.
you a hint. What
Okay.
if you had a giant Maul of the Bear?
Uh. Okay. Bear Giant Mall, Giant Bear Mall. Okay, Giant Bear Mall. I think would still work. Well,
Okay,
maybe you would
have
need
you
to
ever heard
put
about prefixes and suffixes
prefix.
in RPGs, like Diablo?
I don't think. I feel like I have, but I completely forget about it.
Okay, so in Diablo and a lot of other games,
Mm-hmm.
a standard magic item can have two different modifiers, and one of them
Too
has to
much.
be a prefix and one of them has to be a suffix. Prefix
Oh
means it goes
shit! This is like
before, and
Vindictus, right?
suffix means it goes after. I forget how Vindictus names stuff.
They had like spell stuff, or they had enchantments specifically, like prefix and suffix enchantments for the weapons.
Oh, yes, you're right. The enchant system in Vindictus, everything can be enchanted with one prefix and one suffix. So the reason they do this, I think, is literally so you're splitting up the modifiers. You have one before and one after instead of two in a row. I think that's what they decided is you could say like we have a mall and we're going to give it one modifier before and one after, and it's like not too many and they're split up.
Mm-hmm.
So that I think that's why they do that. And it helps especially with like Diablo where it's auto-generated. So they have like a list of 500 prefixes and 500 suffixes, and they will like
Mm-hmm.
randomly, you can get like any random combination kind of. So if you're
Mm-hmm.
having all these random things where you can't where you don't have a human writing it out, then if you had two suffixes and you want to make sure they work together, or two prefixes, like making sure they work together sort of takes human judgment to look at it and be like, can we put those two words in a row? Does that make sense?
Yeah.
But when you split it up and you only have one word at the beginning or one at the end, it's easier to do it without thinking about it.
So like you could have wait, so
So
okay,
they'll just make
prefix.
a they just make a list and they're like prefixes. Um bats, giants, cruel, vicious. I can't spell that word, vicious. Right? And then they're like
Evil.
suffixes. Okay, evil, sure. Suffixes, of the whale, of the stars, or glory, right? Now we have our suffixes. We don't have to like any prefix will work with any suffix because they go in different parts, basically. So we could have
Wait.
an evil maul for glory, which is actually not very grammatical, but I did it anyways. Or you can have a cruel sword of the whale, or whatever. And like, you can replace cruel with any prefix, and it's not gonna, it doesn't directly relate to of the whale. Yeah, and then in Diablo, rare items are items with 3 or more modifiers, and then they have to do different naming, and it's not prefix suffix naming. They just have some other system that makes names that sound cool, but the name doesn't tell you the modifiers. Like rares will just be named shit like Fulbert's
Pulbert's ending device.
sword or whatever. They'll just like they just have some system that makes names that have nothing to do with what the stats are. They're like, it was too hard to make the names match the stats once we got past 2 modifiers, so they just stopped trying.
You could like kind of think about it with like, okay, it's gonna be a sword, so it's gonna probably have stereotypical sword stats.
Yeah, the rares have names that sound less generic. Once you get used to the names on the blue items, the straight regular magic items, you start to see the pattern that they always have like an adjective and then the name of the item and then another adjective. It's always like X sword of the Y. But they do actually have an extra modifier in a sense because they have different item types. So they'll have like a bastard sword, so then they'll be like bastard sword of stars. And they'll have the so there'll actually be two prefixes. One is the type of sword and then one is the magic modifier. Because they have too many different types of swords. They needed to have like higher level swords and lower level swords and two-handed swords and one-handed swords. And possibly like swords with fast attack rate and low damage and swords with low attack rate and high damage. Stuff like that. So they need differences. Anyway, red and cars. Which one is parent and which one is child?
Okay, red, cars. I think red is parent. Then I was trying to figure out cars red. Cars red. Wait, so did the thing we just do
So
have
trying
relevance
to
to
say
what
the
I'm
words out
trying to
loud
figure out?
is not relevant to telling you which one is the parent or the child. So, for example, okay, take Cruel Sword of the Whale. Could you make a tree of that? Do you know where the parents
Okay.
and children are?
So I feel like the starting point would be sword, because that's like the main thing.
Yep.
Like we have a sword.
Yep.
So like would car be the main thing? Like we have a
Yep.
car and it's also red.
Yep. Red is a detail. Just like Cruel and Whale are details.
Okay.
So
I
the
don't.
point there was it doesn't matter if the adjective is before or after. The order does not tell you which one's the parent. English is not written in order from parents to children. This is a very important thing about English. The order does not directly tell you which ones are parents or which ones are higher in the tree. The way you turn English into a tree is significantly more complicated than that.
Okay. So red. Okay.
And
Like.
turning English into a tree is pretty complicated, which is interesting because people don't know that their sentences are trees. And that's actually controversial because there's a different method. There's two like schools of grammar that diagram the sentences in different ways.
Oh. Huh.
And one of them does
It's,
trees and one of them does something sort of like trees, but a bit different.
is one of them? Do you think one of them is right?
Yes. I agree with the tree people. They're called dependency grammar. The other people are constituency grammar. And one of their most famous people is Noam Chomsky, who is also known for being evil about politics.
Huh.
And lo and behold, his grammar ideas were also awful.
Huh. I heard Noam Chomsky and I kind of forgot who he was. I felt like he might have been an objectivist person.
Nope, more of an anti-Semite.
Yikes.
And an America hater.
Oh. America, good. It first country to be about individuals having rights and working from there.
Yeah, so the school of grammar I agree with is called dependency grammar. And the reason it's called dependency grammar is it's about making trees with dependency relationships. So the tree shows you what is dependent on what. In other words, which one is a child that is dependent on a parent. So they are parent-child trees. It's the same thing. Parent-child relationship equal dependency equal part/whole. Part-whole is another way to think of it. which thing is the whole, and then how do you divide it into parts? The whole is the parent, and the part is the child.
Max K thing. If you're okay, Max K said a thing. I kind of want to respond to it slightly. What was I gonna say? Oh yeah, Ayn Rand good on one thing. She good on a lot of things because she has like good kind of underlying ideas or something. I forget exactly. Noam
Yeah.
Chomsky really bad at one thing, which means he has like more likelihood to be bad at a lot of other things because it's like also kind of a really important thing to be bad at, like not thinking individuals really have rights, which is kind of how I feel like he would be.
Yeah, so Max, I agree with you. And for a long time, I was neutral on Chomsky's grammar because I wasn't familiar with it. And then when I found out what it was, I disagreed with it before I even knew that he was one of the people behind it. I think, like, yeah, my opinion of the grammar was not related to my opinion of Chomsky, but then I didn't think it was a coincidence that he was on the wrong side of it. He's also, what I knew a long time ago before I knew his grammar specifics was that he was in favor of the idea that we have like a language center in the brain. He was like, basically, grammar's too complicated to possibly learn, so it has to be built into our brains so that we would all be born with the same grammar. And I think that's retarded.
There's like fucking languages that are very different. Like some
Oh
languages
no,
use
that
kind
one
of
he
like
did think of. That one he's addressed. So they've looked at all the languages and sort of found some similarities. There are some level of similarities between all the current human languages. You
there
might be
can be
surprised.
also like okay. Yeah, maybe. There could be like logical things though. Like if you're gonna make an arrow, then like maybe you put feathers or whatever on the back to like stabilize it from the back. That's like kind of a logical thing, which
Yes.
like any society
Yes, and
would
that doesn't
like
have to
figure
be
out.
built into your brain.
So I'm guessing that's kind of like a logical thing is what the grammar thing is.
There's significant overlap between different languages in my loose understanding. I haven't studied it a lot, but I don't have a strong opinion of that, and I'm not in a position to
Uh,
say he was wrong about that there were major similarities between different human languages.
hmm. So like uh so like there are major similarities, not quite sure why. Could be a lot of reasons. Is kind
But
of your
what they do is
position.
they come up with like a very generic model of grammar and language and stuff, and then they figure out if they can represent different languages with it. And they try to make like this formal mathematical model. And if they make it generic enough, then they can fit lots of different languages into it.
Mhm.
Possibly all of them, I don't know.
Okay, so making it
Anyways,
more generic would like make it less strong of a claim, I think. I remember you saying something. I think it was you
sort
who
of.
said something about like stronger claims being like harder to something. Like
There.
gravity is a very strong claim. Uh, like if something goes up, then gravity would have some
Oh, it
something
applies to
to
more situations and there's like more opportunities for it to be wrong. Like every
uh,
time something goes up, it could be like, well, it
yeah,
should come down. Gravity's like making a prediction again.
yeah. It's like the larger the claim, like the easier it is to
Max,
uh,
that's pretty funny, yeah. See, the thing with Chomsky, though, my loose understanding, which might be a bit unfair with the language thing, is I think that he tried to understand grammar and like looked into it and he was like, this is just so hard and complicated that we must have like an advantage. Whereas I think he would say with programming languages that it's like not as hard and complicated, so it's learnable, I guess. They're a bit simpler in some way. I don't know. But I think it's kind of like that. Like he just sort of gave up on the idea that like babies could learn it. Partly because babies are stupid. I think there's some bias there against children. Because people like don't really think children learn. Like I think that's a major part of it is they have these doubts that like fucking babies and infants are actually learning anything, and if grammar's like really
yeah.
complicated, then how could they learn it? They
Okay.
must like have inborn. And then like once
Babies
they're like, 10 or 20, like and they've grown up and like gotten started and now they know more stuff, then it makes sense they could learn programming.
okay. I don't know much about TCS, but the kind of feeling I have with babies is like they don't really have much to do other than like kind of learn and like look at the world and think about things. Like it
That
wouldn't
is a
necessarily
reasonable point.
be language. Like they don't go on their phone like looking at eBay or whatever and like figuring out what to buy. They're not like really watching YouTube videos either. You can learn from YouTube videos. If they were to
I
do something, it would be like mostly a learning experience because they have no fucking idea what's happening.
Yes, babies learn a lot. People are very bad at paying attention to them and figuring out what they're learning and what they're doing. But that's another matter. But about programming languages, I think that if a lot of kids learned programming by like age 2 or 3, then Chomsky might be a lot more inclined to think that programming languages were inborn as well. Of course, not the entire programming language, just some like basic fundamentals like for loops and recursion and if statements. You just inborn like the core components to be able to learn the details of JavaScript. Anyways, getting back on topic before we wrap up. So dependency grammar says that words in English sentences have parent-child relationships. For example, red is a child of cars, and it gives you more information about cars, and they can arrange English sentences into trees with one word per node, and they arrange the entire sentence, showing which words connect to which other words, and it shows you the groups and the subtrees. Like, you'll be able to see there's like, the teal part of the sentence over here, and the red part of the sentence over here. You know what I mean? But you can see how the sentence is divided into different parts.
Yeah.
So then the other school of thought is called constituency grammar, which
I
comes
don't
from
know
the
what
idea of
constituent means.
constituents are things that build things up. They're the parts that build stuff. Parts that build stuff, that combine to build stuff.
Okay,
Their
so a
idea,
constituency of like an alloy could be like iron and tin or something. Or like those could be
oh yeah,
constituencies.
yeah, something like that. So their idea is like words equal building blocks. You combine them into groups, and you combine enough groups to make a sentence. Now, to some extent, this is a matter of perspective, and you can look at sentences either way, and they both have some use. So it's not like it's all wrong. And the fact that the schools of thought are like fighting so much is a little bit weird. Because you can totally say like it's a parent-child tree, but also you can look at it as like we built up the thing from the building blocks. You can be like, look, these 1 and this 2, they're building blocks, and we combine them with the plus, and we built up a 3 that goes into the this, and like we're just building our way up,
Yeah.
Right, so it's like they're both different perspectives, but there are actual major differences in the schools of thought. So there are significant differences. So the biggest difference is you maybe need to know some grammar, but dependency, verb to subject. So they say that the verb is the parent of the subject. Verb is parent of subject. Constituency, subject plus verb join together to make sentence.
I'm so much more like live much less
They
delay.
are equals / peers. So this is a major difference. They're disagreeing about whether there's a parent-child relationship between the verb and the subject.
The parent child. Verb and subject.
So in I like red cars, so I'll write it out. Okay, so this is the tree I would make. Right, there's my tree. Let me fix this. Okay, there we go. Dependency grammar. So their tree is actually... Okay, so they have I, have like, and then it's really hard to draw using MindNode. I can do it better with Affinity Design. If you actually search for the diagrams, you'll be able to see the difference more, Max. You'll probably pick up on it quickly. Or I could show you after I do this. Where the hell is my window, though? New? I just want a window to draw in. So confused. Okay, we're gonna quit Affinity Designer. Don't save. If you do image search, you can find a bunch of diagrams once you know the keywords dependency and constituency. By the way, there's a third school, which is the we're not academics school of thought, who do the thing called sentence diagramming. If you look up standard sentence diagrams, which are the ones they actually teach in school to like kids in general, they are neither school of thought. They're just like a bunch of special cases and special rules for drawing things. They make like these sort of tree-like-ish diagrams with a bunch of rules for how you just draw every type of thing that exists in English. And it's really silly. And I can
So
show those
instead of
too.
having like good principles, it's kind of just a bunch of maybe arbitrary rules.
The trees you've seen me do would probably be dependency, because that's the ones I think make sense. I never learned sentence diagramming really, but Kate did it, and it's much more commonly known than the real grammar ones. Anyways, okay, so they will do this. Whatever. Close enough. Right, and then we need to take the subject and the verb. So we're going to have I. We're going to have like. And then they say that the like, so these compose together sentence. We'll say SE for sentence. Anyways, and then this is the noun phrase, which is only one word, so we won't worry about it. But this is composed of two parts, which are like and cars. And then cars is composed of red cars. They do it a lot more like this. I guess I ended up doing something I could have done in MindNode. This is not actually their favored way of drawing it. They have a different diagram technique. But so their idea is red plus cars make a noun phrase, and then noun phrase. Let me draw in red on this. So NP for noun phrase, right? So red plus cars together is a noun phrase, and then this is a verb over here. And then you take the verb plus the noun phrase, which is the object of the verb, and they combine to make a verb phrase. And this over here is a subject, which is a noun phrase also. It's just a one-word one. And then a subject plus a verb phrase combine to make a sentence. So this is actually meaningfully different. I will now do the image searches. Anyways, or first I will do the summary, and then I'll do the image searches, and then we'll end.
Okay.
Yeah, YouTube like deletes your messages a lot when they have links in them. It's very unfriendly. You can paste them on Discord and I'll see them. Okay, summing up. Understanding trees is important for understanding grammar correctly. If you want to be able to write and to have debates and arguments and whatever, and to understand what sentences mean, then understanding trees will help you with that. It will help you give it will help give you the conceptual tools, the intellectual framework, in order to understand what's going on in more detail. So you're not just sort of going, well, that sort of makes sense, good enough. Like, if you can actually connect things to parents and child and trees, then you can be like, okay, now I understand it in more detail, I could draw it out in MindNote, etc. Like, it gives you an extra way to look at things that's more precise. So this is useful for understanding sentences individually, and it's also useful for understanding arguments, which can be put into trees where you're like, you have your topic, and then you have your subtopics, and then you have your arguments for each of those, and you can arrange it in a nice tree, like the GM stuff, kind of.
Wait, I don't think I was quite following with like the last 10 seconds.
Okay, let's go to MindNode, so we can be like, social. So you can use trees to organize individual sentences and how the words work in terms of grammar. You can also use it to organize ideas. So you can be like socialism, econ, arguments for, arguments against, economic calculation, and then we can have, arguments for econ cal problem and further explanation. And we'll have some children. Then we can go here and we can go arguments against econ calc problem. We have children. Oops. Well, we can have like nested children too. And then we can go over here and we can go solutions to econ calc that preserve socialism. So like this one is denying the problem, and then this one is accepting the problem but saying there's a way to deal with it. And then we have and then we have a bunch of stuff under there, and then we can fill out this. So you can organize your thinking into a tree. So it's a way of organizing like topics. Does that make sense?
Yeah, you can like organize topics like socialism, here are things for it, then like arguments against it. You can have like one thing, you can have like things, and then you can have like the responses to like the arguments against it.
Yep, so you can organize discussions or like conflicts of ideas or whatever.
Okay.
With a
It's
tree.
like
So
animal rights arguments for,
yeah, you saw those
arguments
ones. I made some
against.
trees for
Yeah.
that.
Yep, that was what I was thinking of.
Yeah, so trees can be useful for that, and they can also be useful for understanding individual sentences and grammar. So they come up a bunch when trying to do philosophy, but most people don't know them, and then they find everything is like too hard and confusing, and they can't get the details right. And then they think, well, I'm just not a genius. And it's like, no, you just don't know basic tools like trees. You don't know how they work. You've never practiced them. It all makes sense if you work through the stuff.
Yeah, so they like can't keep everything in their head at once, like a really large amount of stuff. So they're like, I'm not a genius, I give up, instead of like using tools. Is that a thing that happens a bunch?
Yeah, kind of. They don't even know what the tools are, what the right tools are, or which ones they should learn, or why, and the schools are not fucking helping. Okay, so here are some dependency grammar trees. Except this one has a double parent on help for some reason, but I'm not sure why. Oh, they're saying because there's an implied extra gem. What I would actually do is I would write like square bracket gem. If I wanted an implied word, I would write it as a second node. I would not point to an existing node. Well, you can. It's fine though. I would write this arrow in like a different color or a different font or something. Like I wouldn't want it to look like the normal arrows because it's a different thing. But you could also just write, an extra gem node and point to that. Anyways. When they have arrows in different directions for some reason. Yeah, anyways, I'm not too worried about their arrows, but I think there is a major difference in their opinion of whether the subject and the verb are peers or one is the parent of the other. I think that's a notable difference, and there are some other differences. I've read some of their debates with each other. So there are some real differences, but it's not all real differences. Oh yeah, you're right. Jim could totally have tried to help someone who isn't Jim. Why are they even pointing that arrow then? Did they just assume he was helping himself? Like the arrow reads to me like the person he's trying to help was definitely Jim. I don't know what you mean by saying not substantial. But I've read extensive arguments about why subjects are dependent on verbs. They have a bunch of detailed reasons, which I didn't fully understand, but I understood some of it, although I don't remember it that well. But there's definitely like overlap between the camps that they don't seem to notice. So that's definitely like part of the issue. Oh, you're saying peers versus parents aren't substantial? I don't know, it seems kind of substantial to me. Like, there's the difference between having like multiple root nodes, or it's like a different organization of a tree. Like different places to put nodes in the tree. Anyway, I want to find a constituency diagram. Dependency I don't really have to show because you're those are the ones I always make. They just like seem like standard trees. Oh, ordered. Yeah, I guess if you have like an assumed ordering for every specific case of the peers, then it doesn't exactly matter. Okay, so here is an example of a constituency tree. So what they're doing is they're saying that these words, this and tree, combine as a determiner and a noun to make a noun phrase. And the noun phrase plus the verb phrase makes up the sentence. And the verb phrase is made up of a verb phrase plus a PP. What the fuck is a PP? Past participle? According to constituency. Oh no, a PP is some part of speech which is made up of a P and a PP. And the second PP is made up of a P and an NP, which is a noun phrase. And then the noun phrase is made up of a determiner, an adjective, and a noun. So those three combine into noun, and then you add the... Oh, P is preposition? Prepositional phrase? PP is prepositional phrase, P is preposition. That makes sense. Because I know to is a preposition. Wait, why would according... Double preposition in a row doesn't seem right. And then what would the noun for according be? I don't know exactly how this works. Anyways, regardless of the particular sentence, what they're saying is that these three words here combine together into the noun phrase. Then you take this one, and they combine together into the PP. Then you take this one, and that plus that combines into a PP. Then these two are a verb and a noun, which combine into a verb phrase. And then this thing here plus this thing here combine into a verb phrase. Then you combine that with the noun phrase to get the sentence. So they're looking at it in this bottom-up way, and they have the sentence node as the parent of both the subject and the verb, rather than the verb being the parent, which is I mean, it's a meaningful difference, but it doesn't make their whole systems totally different. Because like you could certainly do the dependency grammar with a implied sentence node at the top, and still do the dependency style. Oh yeah, sentence diagrams. The ones they do in like school though are like these. This is a good example. They do this. This is just this fucking arbitrary bullshit that they were literally like, let's find every special case in English and then make different types of like dashed lines and triangle lines like this and this. And we'll just put it together and make rules for everything. And I don't understand how this is supposed to help anyone understand anything. I mean, I've seen examples where there's
Uh,
some value in it. Like I've seen ones where I'm like, okay, I can see how that helps someone visualize it and whatever. But the trees are so much better. This is a fucking mess.
yeah, when I saw this, my first reaction was, what the fuck?
Yeah, if you do like really simple ones, you can see the point of it some. What's that site? Is it Grammar Bytes? One of the sites like really thinks that diagramming is amazing and wants to teach it, and has a bunch of diagram pages that teach you how to diagram everything. And it might be this website, but I forgot. Wait, if I just search like how to sentence diagram adjectives, I'll probably find it. Oh, good, my mic has been working. I forgot to check that at the beginning of the stream.
Uh,
But it's definitely showing up.
huh. I don't know what the Feynman
Okay.
diagrams are.
Regardless of what I was searching for, this is an example of one that's not that bad. So what they do is they take the modifiers and they put them on slanted lines underneath. So you have like herbivore as the subject, and it's like this is the main word. And then you have the like mini minor words like an and abashed. So it's like adjectives and like the word the. So if you have like the red car, they're gonna have car here. Car. And then they will put like the,
No.
and they will put red down on these slanty lines. So they're putting like the smaller words out of the way, right? So that part makes some sense.
So I think, wait, so is that? I think the first word is I, and then wait, is it?
Oh yeah, I
I
don't
don't know
know
what
why
her.
they have I and then herbivore. I'm not gonna worry about it.
I'm not sure why it's in parentheses. I thought it
Like
was.
I, who are an herbivore.
I thought it
I,
was
I
like an animal at first, and I was like, I, a
oh, I
squirrel
know
or
what it is.
something.
I know what it is. The sentence has commas in it. There are fucking commas here, and that's why herbivore is in parentheses. Or it might actually be literal parentheses. The sentence is like I, parentheses, and unabashed herbivore, end parentheses, like fruit and vegetables. Anyway, so they have this splitty thing for the and, right? So this makes some sense. You're like, oh, we're branching the sentence, so we have like a branch in our diagram. And the slanty lines for adjectives make reasonable sense. But overall, they're a fucking mess and they do really badly with complicated stuff.
So if you were to try to figure out like a science paper with this, would it go terribly?
Max, I don't know if I agree with that. Like, I think it's reasonable to say that a determiner is a type of adjective instead of splitting the category. Or that an article is a type of determiner, which is a type of adjective, if you were going to split it as an article. And even more broadly, if they treated all modifiers in the same way, like adjectives and adverbs, I would be okay with that as well. Because I think modifiers is a good conceptual category. Oh, so this is a nice example. Oops. This is a nice example because of a prepositional phrase in it. They have through in trash the down here. Like, I think that this is reasonable. Like, trees are better, but I can understand why they do this and how it could be useful to some people. Because in the trash as a whole is a modifier, and then within it, like, trash is a noun, so it's on a straight line. Again. Trash is like more of a main word than the or in a sense. So I sort of get what they're doing, but overall they were like, we don't understand trees and we're not going to figure them out, so we'll just make stuff up and make it way more complicated. Kind of like all the programming languages that aren't Lisp, and they were like, we don't understand S expressions, so let's just make up syntax that's 10 times more complicated because we think parentheses are too hard. So making it 10 times harder will definitely help.
Wait, so that's how.
That's how programming languages work. That's not a joke.
That it's not a joke. Still feels weird. I feel like when
Oh, Grammar
Okay,
Revolution. That's the name of the website I was thinking of. Yeah, this lady. Yeah, this lady loves sentence diagrams, so they have a lot of pages that teach sentence diagram stuff.
okay, so huh.
And here you can see some very simple sentences that are diagrammed. And you're like, this isn't that bad. They have a subject, and then this line, and then the verb, and then they have modifiers on slanty lines. And they're like, these are okay. The reason they're okay is because I searched for diagramming adjectives, which is one of the most basic things. So when you get to the complicated stuff, then diagramming index. Okay, so now we have all the different things they teach you how to diagram. Then you go to like subject of infinitives,
What the fuck?
and then you're like, what the fuck is this? Why is there this weird triangle thing pointing up to a different sentence? This is completely arbitrary and confusing. And now they have slanty lines with... Wait, what the fuck? They have curved lines with participles. They're just like, there's too many things, so we added curved lines. And I'm like, what the fuck are you doing? You need a more elegant system.
Did I catch it?
Like, seriously, I hadn't even seen these before. This is ridiculous. They just have so many special cases. They're like, oh, we have to deal with a new thing. We'll just find a new line to draw. Just like those dashed lines in the example I saw earlier.
Uh-huh. Okay, I'm so interested in this Lisp thing though, because it does feel like a joke. You mentioned that it isn't a joke, and this is like one of the first times where I feel like it kind of... This is like one of the first times, I guess,
I will teach you
where
Lisp syntax.
Okay, Lisp.
Okay, here's Lisp syntax. Function.
Okay.
Data, data, data. You can have a different amount of data, like 0, 1, 2, 3, 4, unlimited.
Okay, so what does function mean?
Does
that just like do something?
Yeah, something that does something.
So you could have like plus 4, 5, 6, and then it could be like
Yes, this is literal Lisp code. This will run in Lisp. It will work.
Oh, so they can do prefix.
Yes, Lisp uses prefix because it's simpler and easier.
Is that something people are also afraid of?
Yes, sort of, except not really, because here's how they write functions in normal math. So they think that plus should be infix like that, but then here is how they write like, what's a good example? Okay, we're gonna define our own function. It's gonna add 3 to something, okay? So take one argument and then it returns 3 more than that. So we're gonna call it add 3.
Okay.
So they're like, I won't even bother defining it. Well, sure I will. Okay, define add 3, and it takes x, and then it return x plus 3 end. Okay? Make sense?
So add 3 just finds out what x is, and then it gives you x, but then it also adds 3.
Okay, now how do they call this function in their code? They will do this. Add 3x. This is standard syntax. I'm going to throw in a stupid semicolon.
A stupid semicolon.
Doesn't matter.
And
a lot of languages you have to put the semicolon at the end of every line, and it is very repetitive. Anyways, so this is what they write. They're like add 3, and then they put the parentheses, and then they put x. So what you might notice about this is that it is in fact prefix. The function is first, and the argument is later. Or we can do like add 3 on 7, right? And then it's going to return 10.
So add 3.
10.
Alright, so add 3 is literally just an addition operator? I don't know. It literally just does addition.
Yeah. So this is how they do all functions in general that they custom define. Every time they define a function, when they call it, they put it in front of the things they call it on. So Lisp would be add 3 7, and they're like, no, that's weird. Prefix is weird. We want to write add 3 7. And I'm like, what the fuck is wrong with you people? You're already using prefix for most of your stuff. That is prefix right there.
Yeah.
This is literally how math works, like mathematicians, not programmers. They're always like f of g. of x. Like, this is how they will write the f function is called on the g function of x. It is prefix. But then
So
when they write a plus sign, they use infix.
So do even the mathematicians bad?
Well, I mean, they're using prefix. Like, they will literally be like f of x equals x plus 3, right? This is how math people write their add3 function.
Okay.
They're saying the function of x, called f, returns x plus 3. So whatever you input, and then you can use it, and you're like f of 7 equals question mark, and then you solve it, and you figure out it's 10, right?
Okay, so f is add 3. I think I kind of got lost.
Yeah, f is a function. It takes one
f
input
function.
parameter, which we're going to name x. So x is whatever our user tells us. We're like, we have a function, you tell us a number, and then we will tell you back a number. The number we'll tell you back is we take your number and we add 3 to it. And you can define other things. You could say f of x equals, 2x plus 7, right? So it doesn't, plus 7. So this one doesn't have as obvious of a name. But you could define this, and then you could say, all right, well, what is f of 0? And then you can solve this. Like, you figure it out. What's f of 0?
Okay, I think I'm a bit lost. Okay, so f of x, 2x, and then... Okay, I
Yes,
think
and what is
I'm...
x in this case?
Okay, I think I'm lost. I'm gonna need to figure out things. Okay, so f is function. It's the... Okay, and then the parentheses is just saying what the function is? Or...
It's
I'm not
saying
sure.
what inputs the function takes. Okay, you don't know most of this stuff. Never mind. But let me tell you briefly. So the 0 is... x is like it's just a name.
Okay, it's just
It's
a name.
Yeah. So like
So
it's
like add 3 is
data
just a
1. We
name.
could call it data 1 instead of x, right?
Yeah,
Maybe that's
data
easier.
1. The first piece of data.
Okay, we're going to do 2 times data 1 plus 7, right? And then
Okay.
when we call f of 0, we're giving it one piece of data, which is this number 0.
Okay, f of 0.
We're saying call the function, and our data is going to be the number 0. And then
our
the
data
function has this definition which tells us what the answer is.
Okay, so right now function is... Wait. Okay, I think function is plus 3, but I mean plus 7.
No. Oh, you're saying the answer is 7? Or what?
Function is plus 7.
No.
Oh. Okay, I'm
Because the
not sure.
function is saying you take data 2. You take data
Okay,
1, whatever it is, and you double it.
function. You take data 1.
2x data 1. Here, I'll write it the other way, it might be easier. Data 1 x2. We take data 1 and we double it, and then we add 7. That's what this is saying.
Okay, so data 1, double it, and we get 7. Okay, so if data 1 was 0, and we doubled it,
Yeah, then we get
it
7.
would be...
But what if data 1 is 2?
I was going to say we'd get 0.
Oh, rip. No, so if you set data 1 equals 0, you just literally you take data 1 and you write a 0, and then you can solve this, right? What does this equal?
Okay. Oh, wait. Okay, so if data 1 is 0, then that's 0 times 2 plus 7. Okay, 0 times 2... Wait. Okay, something with order of operations which I want to be careful about. Multiplication happens before addition, so I don't need to be careful with it. Okay, so 0 times 2, 0, plus 7. Okay, we get 7.
Yeah.
Yeah.
Okay, so now if I give you f of 2, can you figure out?
Okay, so we start with 2, we times it by 2, 4, then we add 7, 7, 4 plus 7, 11.
Yep. So that is how that one works.
Okay.
And yes, again, it is prefix notation. So if we were writing regular math the same way that they write it, we would do this. We would do plus 3, comma 4. This is how they do it. They use commas between the numbers. So this would be normal, except that no one does plus this way. So what would that make?
Wait. So plus 3, 4. That would just be like adding 3 and 4, I think. So that would make 7.
Yep. So in this case, data 1 is 3 and data
Okay.
2 is 4. So we
This
can I'll tell you how plus
2
works. So
is
like
4.
plus of data 1 data 2 equals data 1 plus data 2.
Okay.
Assuming you already have plus defined, you can define plus. Like if I had to define plus with other stuff, it'd be harder, but I don't want to get into that.
Okay. I don't quite understand what defining plus is.
So it's tricky to define plus if you don't already have a plus function. What I did here is I defined a plus function that assumes you already have plus, because I used plus when I was defining it. It's like defining a word in terms of itself.
Okay. In terms of itself. So like defining something is like something you have to do in programming. Like when I type purple, I want you to remove or subtract 2 from X. So like you could define
Yes.
purple as that, and then like every time you type purple or like purple data, it's like data could be 5. So purple data equals 3.
Like this?
Yeah. It's like purple X
Yeah,
minus
you can
2.
do it that way, Max. Just give it a different name. I was trying to say that like the plus function we already use could be written with the function call notation.
Okay. Wait, say the last thing again.
The plus function we already use could be written with the function call notation. Like just like I had
Like
add 3, it could be like,
in
you
3.
know, in this case, you could use plus in the same way. People just don't. They're really used to infix.
Yeah, use plus. So they want to use infix even when they already use prefix and could easily swap to prefix, and it's not a
Yeah,
problem.
they're already used to writing this. This is
Okay.
what they write for most stuff already. Like programmers and mathematicians already use this a lot with stuff that isn't plus.
All right. So with plus, it could be the add 3 program or something. Like instead of plus, it's could be like take these 2 data points, add them together, then also add 3, and that
Sure.
could be what plus is instead. And they would be used to writing that easily. It's like
Yeah,
not a problem for them. But then they're afraid of Lisp because you have to do prefix.
that is. I mean, it's not the only reason, but yeah.
It's like a
Anyways, I was trying to
contributing
teach you the
thing.
syntax of Lisp. So function, data, 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 data. Okay?
Okay.
So a
Okay.
function such as plus and data like numbers.
Mm-hmm.
But you can do it with other stuff too.
Mm-hmm. So what would happen if we put the add 3 program in the function and the data was like 4, 5, 6?
Right. Then you would get whatever 4 plus 5 plus 6 plus 3 is. Assuming the add 3 was defined to be able to take multiple arguments.
Oh, I was assuming it couldn't take multiple arguments.
Oh, well then you
Uh,
just get like a crash or an error or whatever.
huh. I don't know what multiple arguments mean, but I kind of just guessed I knew what it mean, like multiple things.
Like this one here has the plus has 3 arguments. The arguments are the
Okay.
data you're giving as input.
Okay. Arguments are the data.
A,
Okay,
a
so plus is
function
3.
takes input and then it has an output.
Okay, a
So the
function takes
inputs are
input
like the data
and it
you
has.
give it, and the output is the data it gives you back when it's done doing whatever it does. It does some sort of calculation, and then so it takes input data, does a calculation on it, and then it gives it back. So it's take something, do something to it, and then give back a result.
Take something, do something, and then give back result.
Okay,
Okay,
make
yeah,
reasonable sense.
so,
And so plus
yeah,
is an example. Plus takes some numbers, let's say 2 numbers as input, and then
okay,
it gives
plus
back an
takes,
output, which is whatever the fuck they add up to.
yeah, it's like plus, uh, okay, plus, take the numbers, uh, add them together, and then what is the result? Output. Like, plus, it takes input data, does some fucking calculations, and gives output.
Yep.
Okay.
Okay.
And then
so,
add 3 also does that.
Yes. So programming in general basically consists of lots and lots of function calls.
Lots of lots
There's
of
some
function
extra
calls.
details, but basically you call functions and
Okay, so
you
function
call
call
more
is like
functions, and then you call
do
even
this
more
thing.
functions, and eventually the computer does all the things you want.
Okay, so function call is like we could call purple to like come do something for us. Like, hey
Yeah.
purple, we have a number, do what you do to it. And then
Yeah. So
purple
with a
like
computer,
does the calculation.
the function call is like an order to the computer, do this task for me. Okay, so this is Lisp syntax.
Okay, Lisp syntax. Yeah,
Lisp
seems
syntax
easy.
part 1. Yes. Okay, now I'll show you Lisp syntax part 2.
Lisp syntax part 2.
Yes, so Lisp syntax part 2 is you can nest the function calls. So
Oh
instead
shit,
of a
this seems like
data,
trees.
you can, yes, you make a fucking tree. So instead of, so for example, we can have plus 1 plus 1 1 1. We can do that. This is Lisp. So you can have a function and data with prefix, and you can also nest it. That's it. And
So I've
then,
secretly been learning Lisp all
right.
this time.
Yeah, kind of. Okay, so part 1, part 2, done. Part 1, prefix. Part 2, nesting. Part 3, there is no part 3.
Okay, and the slash slash is just like text you
Slash
can
slash is
put in so it
comments.
doesn't interfere with anything.
Yeah, slash
It's
slash means
just
not code.
yeah, so it's like tells the computer just ignore this, okay?
Yeah. Slash slash was from C, it's not Lisp. Lisp actually uses semicolons for comments, but whatever.
Semicolon. Yeah. So that's the thing to the right of L, and E is a shift, I think.
It does not use shift.
Is it just the thing to the right of L?
Yeah.
Oh.
The slash slash is much more well known than the semicolons. The very well known comment characters are also hashes. Comment, and then there's multi-line comment, blah blah blah, blah blah blah, and then you end the comment like that. These are the most common ones. Lisp does it's either one or I forget if it's 1 or 2 semicolons, and then you can write your comma after it. Anyway, a comment just means it's not code. It gets completely ignored by the computer, so you're just writing notes that other programmers can read or yourself.
Yeah, there's something with like source code leak, and there's like a lot of kind of comments about the source code being dumb from the programmers themselves. Have you like seen any of the videos of like the compilations?
No. But what I did see
There's
today is some company is doing like a session, like a hacking session, where they're like, our programmers are going to spend a bunch of time on this project all weekend or something for the Juneteenth like bullshit holiday thing. And the thing they're going to do is they're going to go through their code, and they're only going to fix comments. They're not going to change the code, only the comments. And then they're going to look for racist comments and delete them. That's their big hacking project. They're going to look through their whole code base and edit all their NPC comments out.
Wait, what?
Yeah, I'm not joking. That's what tech companies think they need to do right now.
Next game messages. Okay.
That's what I saw on Twitter today. And yeah, Max, I wasn't really trying to teach programming. It's just like it's sort of hard to avoid Lisp if you're gonna teach trees and like turn them into like text and back and go back and forth and learn how parentheses work and stuff. So yeah. But they're not even the goal. The goal is like actually to be able to use trees in philosophy. Oh, like fixing actual comments issues, I agree with, that's okay. But looking for the racist comments is not yeah.
Okay. So how hard is Lisp to learn?
The basics are not that hard because you could already write Lisp programs that did math. There are harder parts.
So like if I somehow managed to like figure out how to download Lisp and run it, I could like write the math trees
Yes.
and I could make Lisp run them for me.
Yeah.
Red flag trees.
Let's try to do that right now. All right. See, I brought up this terminal window and then I type brew install closure, which is a Lisp that is like modern and might install from homebrew. And it might give me a command line programming or a REPL. But you know what we can do? There's a fucking easier way to do this. Online REPLs. There's some site. REPL.it. Yeah, that's the one. Okay, how do I switch languages? I don't want Python. I'll just go to their homepage. Okay, this is a site where you can just type in code and it'll run it for you.
Uh-huh.
Features. Where's the fucking Lisp one? Oh, somewhere on the site you can change the language. Oh, did I find the right button? Okay, closure. Here we go. Okay, and then I can take this code and I can type it in and it will tell me 4. Should work. Why is it not giving me an answer yet? Did I forget a parenthesis? Did I add an extra parenthesis? I did. Okay, we're gonna delete the extra parentheses. We're gonna kill it. How do you kill it? Okay, well it died. Oops. Okay, now we do it without an extra parentheses. Will it work? Maybe you have to like use print or something. Why is this not working? Stop. Alright, run. Will it run this?
Bruce seems to be installing something, whatever.
Yeah. Alright. Closure. Can I type it now? Oh shit, I can type it. Alright, closure -- help. Okay. Oh, eval string. Alright, there we go. Closure -e this thing. Oh, it downloaded like 6 things and then it figured out the answer was 4. And now it works without downloading. Yeah, there we go. I don't know why it doesn't work in the online one, but it totally worked when I just ran closure. What is wrong with these people? Let me refresh this web page and then type it in correctly the first time and see if it works. Nope, I don't know what the fuck is wrong with this website, but yeah, I ran the actual closure app, and -e meant evaluate the string I give it, so you can just type your code in on the command line, and then it ran,
is
and it gave me 4.
Yeah. What does compile mean? I hear that a lot. I don't know what compiling is.
Oh, so you write your code in a text file, like, so we have all this code, like, pretend this is code.
Yeah.
The compiler takes your text file, which is human readable, and it turns it into the thing the computer can read.
Oh, right. I think I know something about that.
Like
kind
an exe file.
Really.
Exe files are like meant for Windows to read instead of for a human to read.
So if you like tried to read it, like technically you could if you knew what everything was, but it's really fucking hard and doesn't really make sense.
It's just
and
it's
would be
like
so
lots
hard
and
to
lots of
edit.
ones and zeros, and that's it. Yeah, so if you can read like 5 million ones and zeros in a row, good luck.
Oh yeah, like each letter has like multiple ones and zeros. So...
You know, they're getting rid of the letters. Like they don't base it on letters. They base it on like the chip design, and the chip takes like certain series of numbers and certain lengths of the numbers. So it's the chip will look at it and be like, okay, I'm going to look at the first 8 ones and zeros, and I'm going to read that, and then it's going to be a number, and then that number will tell me the next thing I'm doing, and then I will look at a certain number of ones and zeros after that, and then do the thing that the previous thing told me. It's kind of like that. So it's not like there's any letters left at all. There's no English left. It's hard to read. You would have to look up the documentation for the chip architecture, and then figure out what all the numbers meant and translate them back into something that you could actually understand. And it would take a lot of work, and you should use a computer to do that. And even when you use a computer to decompile things, it's called, it's kind of messy and hard, but it's possible.
So it's like decompiling really fucking hard, and is kind of what you do if like the source code wasn't released or something.
Yes, sometimes people don't have the source code, so they take the app itself and they try to recreate the original source code. And getting it to the point where it's actually readable is difficult.
And so like readable doesn't even mean like this is the actual source code. Now we can like make all the modifications we want to it. It's just like can kind of see what's happening.
Yeah.
Huh.
Okay. Anyway, so yeah, that is how Lisp works in short.
Okay. Basics
That's it.
seem very easy.
Yes, so that is why I told you that the other languages made things 10 times harder than just parentheses, functions, data. That's it. You're done, you know? And you
yeah.
thought you were a little bit skeptical. So, okay, we have 3 things to worry about in a way, parentheses. Okay, now we're going to look up a different language. Let's look up Ruby keywords. So these are all things that are especially designed in the language to have special meaning.
Okay, specially designed to have special meanings. So like we can't really turn what's it called? Purple. Like if purple was one of the keywords, then we couldn't like have purple to take away two. Like it's already a base word, like sorry, can't use it kinda. Would that be
Yeah.
accurate?
Yeah. So they have these built-in special things. So Ruby has this many. Some languages have way more. Lisp, actually, I didn't go over the keywords, but you need a few things to get started with in Lisp, but you can do it with 7.
Hmm.
It's more convenient to use more, but you can do it with 7, which is a sign of how elegant the language is, that you can just be like, all right, we've defined 7 things to get you started, you can do the rest from here. Anyway, here's some Ruby keywords. I don't even know how to show you Ruby syntax, but Ruby is particularly bad, and it makes it hard for compiler writers or interpreter writers, and makes Ruby slow because the syntax is so... they wanted to make it human-friendly and convenient, so they made it more problematic for the computer. Which is both good and bad. Lisp, on the other hand, is extremely computer-friendly. Right, the computer can parse lists with parentheses very easily. However, it is also human-friendly. It's both at the same time, because it's fucking simple. Whereas all the other languages are kind of like, we're going to pick one or the other. We'll make it like friendly for the computer or the person.
Right.
Because they're
So if you
adding
have
all
a
these complications. And it's hard to have it both ways when it's complicated.
So if you say program a video game in a computer-friendly language, does that mean it will have more performance?
That is the rough idea, but in practice that's false because so like theoretically the language is faster, but the largest factor for how fast a program is the design from the human. So if it's harder for the human, he will get confused. When he's confused, he will write less efficient code because he's having a harder time figuring out what he's doing. So it will actually end up slower. So you get the worst of both worlds.
Yeah. I remember you saying something about computer speed in relation to like humans, and I guess it also like can relate to or programming language speed in relation to how good the human is. It's like if you have a bad human, then like having bad computer language might help the human to make it faster for a computer to run. Wait, what am I saying?
Sort of. Anyways, yeah, the important thing is that the human doesn't get confused and can actually figure out what he's doing.
Main bottleneck human, not the language, probably.
But yeah, the other thing is, right, bottlenecks. So computers are fast. So most of the stuff goes really, really fast on computers, and how fast it is doesn't really matter. If it's like 1 nanosecond or 5 nanoseconds, you don't care. So
Yeah.
the way you make a fast program is you find the 1% of the code that is the slowest, and then you make that fast. And then you're like, cool, it's fast now. And you ignore the other 99% of the code because it was already fast enough. You just find the
So
worst
like,
parts and you fix
yeah,
them.
maybe like 1% of the code is like the fastest, but it also has like so much room for improvement. Instead of like 5 nanoseconds, we could make it 1 nanosecond. Uh, but then there's like another thing which takes an entire second to complete, and it's like one of the hardest to optimize. Like, you could optimize the 5 nanosecond one to be 1 nanosecond, but that doesn't matter like at all.
Yeah. When you have something that's 100 times slower than something else, that's the one you need to optimize. And most of them are just fast. So, you want it to be human friendly so they can do a good job of figuring out where the slow parts are and fixing those. And you don't need your entire language to be fast because most stuff is fast enough anyways. What you want is to be able to go fast in small parts of your code where you need it, and the rest of the time you just want it to be completely human friendly and easy because speed doesn't matter. So if you're trying to have a fast programming language, that means you're trying to make everything fast, when only 1% actually needs to be faster.
It's like
What you
99%
really
of the
want,
code's already fast. Who cares? Why
yeah,
make it faster?
what you want is you write in a language that's very slow and human friendly and who cares how fast it is. And then like what you want to be able to do is use more than one language. So you can take a section and say, I'm going to write this section in a fast language. You only do that for a couple hard parts.
Mhm.
That is one of the good ways to do it. Like you write Ruby, but then you get to a part that has to be super fast, and then you write that in C instead of Ruby. And you make the two languages work together, so you have the slow, friendly language for 99% of your code, and you have the fast, annoying language for 1% of your code.
So like the 1% that really needs performance, you can use computer-friendly language for.
Yeah, but there's
And then you
no
could
reason
like,
to use a computer-friendly language for your entire program.
yeah, so you could like have it so like the best, most expensive programmer you have works on like the computer-friendly stuff that's not user-friendly. And then like your other coders can just work on the basic stuff where it's like not too much of a problem.
Yeah, although it's not really, you don't really want your best guy on that. What you want is the guy who knows how to do that kind of thing. Like, it's more like a different skill
Uh,
rather than, it's like some people
okay.
will be specialized in that and some people will be specialized in other stuff.
Huh.
But yeah,
Okay.
some languages like Ruby and Python are built on top of C, so they're designed so that you can drop back down into C when you. And C is built on top of assembly language and is designed so you can drop back down to assembly language when you need to be faster.
So can Python go back down to assembly?
I think you can do that, probably. Never
Huh.
done that, I've never tried to, but probably possible somehow.
Hmm. Optimizing hundreds.
No? Oh, Python has some system that doesn't allow that, apparently, says Max.
Hmm.
Oh, right, but no, but what about like actual C modules for Python? I don't know how that stuff works very well. I know with Ruby though, you can like write actual C files. There are like Ruby extensions where you have to like run your C compiler to install them. So I figure you could have assembly in there somewhere, but I've never done it. And I thought Python was similar. Okay, yeah. So there is some way with Python, but it would be unusual to use assembly, I assume.
Okay, so I guess C++ is like a fork of C. And I guess C is a fork of
Uh,
assembly, and Python's a fork of
no,
C.
no.
Oh, okay. Misusing the word.
Yeah, so a fork is when you take a copy of something and then start editing it.
Right, okay. Fork, you take a copy, so you could like, I could make a fork of an iPhone. I could have an iPhone, and then I'm like, I want this to have spikes. and then I put spikes on it.
Sure. Yeah. So these other things, they're related, like they have design similarities or one uses the other or something, but it's a different relationship than we're going to make a
Right.
copy and then the reason people fork stuff is they disagree about what features it should have. The one guy is like, we should have a blue homepage, and the other guy's like, well, no, it should be red. So then they fork it, and then they each have their own copy, and one of the guys makes it blue and the other one makes it red.
Is it always like there's disagreements, or is there sometimes where it's like having multiple forks would help with different things?
Yeah, it could be the second one. You don't have to have an argument. You could just think it'd be useful to have multiple things that like come from the same original thing, but then they have different goals.
Is it arguments like a lot of the time though?
Uh, I don't know how often, but their arguments are definitely a thing.
Hmm.
I know that that Nginx forked off of Apache. Those are web servers. I don't know how hostile that was or not, but Nginx was like, we want it to be simpler and cleaner and faster instead of like really complicated and bloated and overloaded like Apache. Which is a bit of an insulting way to talk about Apache, but not necessarily. Like the Apache people could be like, oh yeah, like we just like bloated things because we thought having all the features was worth it. Features are good. Right, so there's like room to have the
Yeah.
like less features or the more features version and have different things.
Yeah, like if you have a really high feature thing for like maybe a small program, then like maybe you could make all your small programs with this high feature language and it doesn't matter because the performance is whatever. It's a small program.
Oh, I didn't know that, Max. That's funny. Yeah, on the other hand, I'm okay with never using Apache again. So that's my opinion.
So like you wouldn't really want to use Apache in like a big complicated website?
I wouldn't want to use it for any website. It's
Oh.
just much more trouble than Nginx is.
Hmm. I don't know how website stuff works. Are there like specific website coding things?
Uh, yeah, those are a thing. The web server is different, though. It's a different tool. It's not about the programming. It's about
No.
it's a tool that like it's the thing your browser talks to.
Hmm.
It's a thing that sits on a computer and waits for browsers to connect it to it. And then the browsers send requests like, I want this web page, and then the web server says, oh, that one, let me find it and send it back to you.
Hmm. So is that how you can like sometimes have browsers not or websites not work with certain browsers?
Yeah. Well, that's usually not the web server's fault. It's usually the
Oh.
data in the web page is incompatible with the browser because the web page has HTML and CSS and JavaScript and maybe some other stuff. And you can use features of those languages that the web page that the browser doesn't know.
Oh yeah, so like if you're on some kind of video game website or whatever, like and you have JavaScript turned off or something, then like maybe there you can like
Right.
navigate it, but you can't use the Java programs.
Yeah, but also the JavaScript in Safari and the JavaScript in Edge and Firefox and Chrome all work slightly differently. So you could find some JavaScript program that will work in one and won't work in a different one. This used to be a bigger problem in the past, and people have known for a really long time that it's a really big problem, so they've put a lot of work into standardizing things so that so it's easier to make a website that works for everyone.
Okay, so having like good actual reason. Oh wait, Max K is talking about multiple languages. It seems like it would be good to have like specific defined reasons for why you use each language instead of kind of just being like, oh, whatever, I'm going to use this language for no specific reason for this project. It would make sense to do that if you want to like get more used to a language, though. That'd make sense.
Yes, different languages have different strengths and weaknesses. C is one of the ones that actually has a good reason to exist. But is way, way overused and should be used for way less stuff. But there are actual use cases where you should use C.
So C is good for a specific thing, but people use it for not that specific thing too much.
Yeah, unlike PHP, which we could have just never had and it would have been fine.
So PHP shouldn't exist.
Yeah, it's pretty questionable.
Okay, and it got really popular because like something happened. Maybe it had like one really nice feature which people wanted to use from it.
Yeah, well, there was WordPress and there was bulletin
Okay.
boards. There was a one called PHP which is a bulletin board software for PHP that was popular. Well, no, I'm saying PHP never should have existed. That's basically my opinion. People should have never made it and just used Perl or something else, or made something that was less bad. I think that was a reasonable thing to have done at the time.
So instead of use Perl, instead of use PHP, make bulletin board and WordPress for Perl or whatever.
Yeah, sure. Perl's just like significantly better and older. And if you really want some like dumbed down friendly language, you could have made it much less horrible than PHP. PHP like wasn't worth it, in my opinion.
So if there's like
I think a world where PHP never existed would not have caused trouble for you, Max. Like if you had to learn Perl or something else instead, you would have been fine. There's other languages that are a lot more borderline, like Ruby and Python and JavaScript, which like you can complain about them in certain ways and say, well, we had Lisp like long before them, which was clearly better. But like those languages are reasonable tries in a way that PHP is worse than. Like they make a lot more sense than PHP.
it's like PHP is why did you even bother, and like
Yeah.
Python is like, oh yeah, that would make sense for why you would bother.
Yeah, there's some merit to it. Like I can see some good sides to it.
So what is programming? Uh, okay, Lisp programming language, big things for big things. What about small
PHP
languages?
taught us a lot about web security flaws. I'll give them that.
uh,
But not in the way you'd hope.
uh,
They're big fans of global variables and user settable global variables. And I've barely used it, but I've seen a little of that stuff, and it's ridiculous. Yeah, I mean, I know there's some reasons people made it and what they were trying to do, but oh well.
Okay, so what would happen if you tried to use Lisp for small programs, and what would happen, and what is like good languages for small programs?
So Lisp is fine for small programs, except so to make small programs today, what you need are powerful built-in libraries. So your language needs to come, or you can install optionally, a bunch of features. So it like already knows
Yeah,
how to do a million things, like make a
so
web
like
server or
Purple could
read
be
an
a
XML
library
file.
for like -2.
Right, but you want it to know how to like read an XML file or take
Reading
an
next
image
one.
file and resize the image and make it smaller, for example. Right, so if
Oh,
you want your
yeah.
program to be short, you want that to be built in, and then like resizing an image will be fast if that's built in. If
Oh
it's
yeah.
not
So
built
if
in and
you
you have to
like,
resize an image yourself, then it's going to be long.
so like, if you wanted to make a new painting software thing, you could like have a library that already has the resizing feature in it, or you could try to make it yourself.
Yes.
and
So
that
you
would be
need
like
to
a
be
lot
able to
harder.
hook your program up to an image processing library, such as ImageMagick,
Mhm.
or Devil, and get all of their features, so you don't have to make them yourself, and that's how you make short programs. And Lisp has a reputation at not being very good for that because it didn't get enough love and effort and stuff to integrate it into modern things over the years. It's an old language, but it's not popular enough to have a lot of people putting the work into making libraries for it.
So
However,
if
there's this new version of Lisp called Clojure, which is compatible with Java. And the purpose of that is Java is a really popular language that already has a million libraries. So they were like, we will build Lisp on top of Java, and then you can use every single Java library. So now you have all the libraries you could ever want.
that sounds really fucking good. Is there any problem with it?
There's some
Is
problems, but basically it's a good idea.
hmm. Wait, so is Clojure a different language or
Clojure is a version of Lisp that is compatible with Java libraries.
okay, it's just a version of Lisp. Okay.
Yeah. Lisp is Lisp is not a specific language. Like C and Ruby and Python are single languages, like this one single thing. I mean,
Yeah.
Python has like version 2 and version 3, and they changed some stuff, but basically it's like a single thing. Lisp
Yeah.
is a category of languages.
Category.
It's an idea of how to do a language, but there people have made different Lisps that are similar but a little bit different. So Clojure is another one that's similar but a little bit different, with the particular feature of the Java compatibility.
So you could have like a theory kind of like how to make a language, and then you could like call that theory like Lisp, and it's like what should a language have? Like blah blah
Yes.
blah.
For example, it should have parentheses and prefixes.
Does PHP have that?
No, sorry.
Okay. What are good languages for small programs? Did I already ask this, and did I already get an answer? I
Yeah,
forget.
ones with libraries.
Oh yeah, libraries. Right. So you don't have to like make the feature yourself, so you can like resize an image without having to program it to begin with.
Yes.
Okay. That makes sense. So you can just like pull features quickly out of a library. You don't have to make it yourself. You can just like kind of do it quickly.
Yep, so Lisp is perfectly fine for small programs as long as you have a bunch of libraries,
Yeah. So
just like Ruby
Clojure
or
would
Python, which
be
are known for that.
yeah, so Clojure would be like pretty good for great for small languages,
Yeah,
assuming
it's good.
everything works.
Should be good. I haven't used it and seen like exactly how convenient it is to use Java libraries, but it should at least be decent. Java, by the way, is another language I particularly dislike and
Mm-hmm.
question the existence of.
Mm-hmm.
They
What
were
do you
like, let's.
dislike?
So Java's idea was lots of people know how to program in C. So what we're
Mm-hmm.
going to do is we're going to take C, and we're going to make it way wordier and much more annoying to write. And we're going to try to make it a little bit friendlier. And we're going to add garbage collection and a few other things. And people will write it because it's not confusing to them because it's similar to C. And so they're trying to like iterate on C and add some extra stuff and so on. So from that perspective, the project makes sense. They're like, we're going to take C, we're going to add a few things to make it better, and we're going to make it easy for C programmers to use. And the way they made it like extra wordy is annoying, but whatever. However, there's a different way of looking at Java, in which case it doesn't make sense, which is the purpose of C is it's very computer friendly. It gives you speed because you're writing in a way that is like close to the bare metal, close to the CPU.
Mm-hmm.
Java is in this like no man's land of let's get further away from the low level details, uh, but then not really go very far. And it's like, why would you do that? If you want a high level, powerful language, you should go way further away from the low level details. Why just like go a little further away and stop there?
Mm-hmm. Okay, so C is like a computer-friendly, not very human-friendly language.
Yeah, C is just like, let's take assembly language and make it like more human friendly.
It's like the C ratio might be like 90% computer, 10% human, but then Java's like, let's make 85% computer, like
Yeah,
15%
I
human,
mean,
or like
even
maybe they.
originally, Java was only like twice as slow as C, right? Like it wasn't really that bad in terms of speed. It's not like they made it too slow. It was still okay on performance. It's just like it's a weird compromise to be like C has an actual niche, a purpose to it, and then Java was in a bit of a no man's land. That's what I think. Whereas if you want a language to actually be good and nice, you should go much further in the high level language direction and be a lot more like Ruby or Python, if
Yeah,
not Lisp.
I guess what's high level language? Like C is
High
like trying
level
to.
means higher level of abstraction, so less like how computers think and more like how humans.
Mhm. Like, high level. Uh,
So like C is like say so let's say 0 is how computers think and 100 is how humans think. And
yeah.
C is at like 10 and Java's like, I know what we need. Let's go to 25.
Mhm. But there's like,
And I'm
okay,
like,
so if you wanted
wait,
to,
why not use 90?
yeah. So like, if they could come up with reasons for like 25, that would like maybe make sense. Like, oh yeah, that would make sense as a reason for 25. But like, if you don't do that, it's just like, why 25?
I agree with that, Max. And Lisp never really had performance problems. Like,
Huh? The stream
Lisp was
ended.
never like Ruby level performance problems or anything remotely like that, or Python even. That was never the real issue. Yeah, 90 doesn't actually have to be slow. There are definitely ways to be computer friendly and human friendly at the same time. But anyways, C is a particular way of being computer friendly that is like less human friendly in a lot of ways, although not all. And but it's reasonable for it to exist because it's actually similar in a reasonably direct way to how computers work. Like, okay, that makes sense. And then Java is like, let's go further away from that while staying kind of similar. And I'm just like, it's a weird compromise in my opinion. I kind of see why they did it and why it got popular, but I don't like it. Pascal is fine, of course. Like that's a thing that makes sense. Oh yeah, there have been lots of Lisp runtimes. Like there were old Lisp machines. Yeah, and Java had like actual useful things. Like it had some like error catching stuff that was better than C, like the way they do their begin catch type stuff, right? And they had the garbage collection and they had some object oriented stuff that I guess was kind of like C++, but an advantage over C.
So is there a quick way you could tell me what Haskell is?
It's mathy and weird.
Okay.
In a different way than Lisp is mathy and weird.
Hmm.
And weird is like based on people's conceptions. Like it's not like a real comment, it's just it seems weird to most people.
Mhm. Okay. I haven't thought about weird much. Uh, it makes sense if it's not like an exact thing. Like bad could be an exact thing, like don't do it. Uh, that's like more of a direct thing.
Haskell's got to be
like
useful for something, I think, from what I know about it, which isn't all that much. But it seems like there should be some niche there.
Haskell's just like theory, and then so
Yeah, they're trying to be like abstract and elegant. There are a variety of other like semi-obscure things like ML and OCaml, Prolog, that have like mathematical reasons that there's something good about them, but they're not very popular.
hmm.
But there's some sort of like design principle that's worth exploring to them. Lisp is a particularly old and generic one that just makes a lot of sense
Hmm.
and
So
is
I,
not as popular as it should be by
oh
many.
yeah, I really like your ahead of like how far ahead of a time a thinker was. Like you kind of just like look, okay, when did this person come up with their ideas and when were they superseded? So you
Uh,
can like
yeah,
uh
Lisp is doing well there. Like, it has not been
mhm,
superseded. There's stuff that's like stuff has caught up some, but there's nothing you'd be like, well, we don't need Lisp anymore now that we have this.
yeah. I never like really thought about things of ahead of their time like that until I don't think I thought of them like that at all until I saw you like use that in like your Elliott Temple website. Uh, or no, I think it was the
Did I
book's
mention it for like
recommendation.
Godwin or something? I think I said
Yeah,
Godwin is
William
still not
Godwin, like
superseded, so that's
200.
like a yeah,
Yeah.
that's a pretty good record for how old he is.
Mm-hmm.
Definitely one of the best.
Oh yeah, they're like visual languages. What's a visual language?
Yeah, that's a reasonable ballpark max. I don't know what the number is. It might be earlier, but Lisp is like it's like really early, like before they had computers, I think they were sort of like thinking about like how would we organize this and how would we do this, and I think it's partly related to that. Like you had these mathematicians like theorizing about how you would do it.
Well, Lisp is like early 60s and it's still good.
Yeah,
Huh.
yeah, because the mathematicians, some of them knew what they were doing back then.
Mhm.
Like knew how to make something that actually is principled and like elegant and simple. Like you saw the I taught you the Lisp syntax, right? Like you
Yeah.
can see how a mathematician, even before computers existed, could be like, well, we'll have parentheses and then, like someone could
Right.
think of that and be like, well, this makes sense and it'll keep everything really simple and organized.
Mhm. Especially if you're like maybe doing pen and paper stuff, you don't want to have to like remember a bunch of things and then like, oops, I messed this thing up. I need to like erase that or whatever.
Yeah. And so all of the other languages are they're also writing trees. Like you saw how to convert Lisp into a tree and vice versa, right? We did that a few
Yeah.
times. We're
Like with
turning the
Lisp into a
parentheses things
tree.
into trees
Yeah.
and back,
Yeah.
right?
We
So
can
every other
do that.
language also has to be turned into a tree. That's part of what the compiler does, is they figure out
Yeah.
how do we turn this language into a tree.
Oh yeah. So if this Lisp code specifically, okay, we start with the plus, and then that's the base tree. Okay. Then what do we get?
So
Oh
the
yeah.
other
Remember.
languages are basically like more complicated, confusing ways of writing trees with more special cases.
Hmm. Okay. Uh, then
Because
one
some people, some mathematicians who are ahead of their time are like, special cases are stupid, let's make this simple.
special
And a bunch of other
cases.
people are like, let's have lots of special cases.
Okay, I made the Lisp code into a tree.
Discord. Oh, yep, that'll do it.
Okay, so have the mathematicians maybe gotten worse in some way, so they like uh, don't do good? I'm not sure what I'm saying.
No, it's just that there were like a few good ones then, and there's a few good ones now, I think.
Okay, so there are like a few specific good people, like maybe a Feynman or two, who like
Yeah.
came up with a language.
Yeah, so what Max just mentioned is the other way you can do a tree is you do like this. Okay, you got the idea, like nested bullet points. Would you know how to make that into a tree?
Uh, yeah, it seems a bit hard because there's a lot of stuff that starts
Okay,
with a J.
there you go.
Like, this would
Let
be
me switch earbuds.
easy. Like, I can literally just like follow one of the columns, like one of the hyphens, and just like make as many as are there.
Anyway, Python
Okay, on the
works.
second one.
Oh, hold on. Earbud is not connected. Okay, there we go. Yeah, so Python is like this, except you don't write the hyphens. You only use the white space, the tabs.
Mhm.
Yeah, Ruby was designed by Mats, who was like, let's take Lisp and remove S expressions and macros, and then add Perl conveniences. So that's why it came out pretty good, except not as good as Lisp because he intentionally made it worse in two ways. Like, and that's not just like an interpretation. Like he said something along those lines.
Mhm.
There's like a quote somewhere. But it was originally called Matt's Lisp, but he removed S expressions and macros on purpose. Or never added them, but like it was a design decision. And yeah, Perl was also a major influence. That's why I used a gem name. Now he knew what he was doing.
Wait, so does it work with any language to turn it into a tree? Or like, I guess I should start specifically. Can you turn any Lisp program into a tree?
Yes. So anything with the parentheses like this, you can turn into a tree.
Yeah, they could literally be any text, and I could still make them a tree, as long as
Well, as
there's
long
the
as you don't have like a
parentheses.
syntax error, like, suppose I do this. Delete, delete. There we go.
Uh,
Right? Now it's broken.
yeah, as long as there's one opening for one. Every opening has one closing, uh, and every
Well,
closing has an
we can
opening.
still break it. So, like, we have three
Oh.
openings there, so let me put three closings right here. How's that?
So this is bug fixing with language, huh? Or like
So
with
you have
programming.
to have, like, you can't go below 0, currently open parentheses.
At least one closing, or exactly one closing parenthesis after every opening parenthesis.
Uh-huh, yeah, something like that. So basically, as long as you don't do anything dumb, it'll work.
Carp language.
So then other languages are also trees, they're just written in a less clear way.
So they're trees, but not as clearly trees. So like, what's happening?
Just like English sentences are trees, but it's not obvious what trees they are. Right?
Hmm.
If we would write English sentences using the parentheses and the prefixes like S expressions, these
Hmm.
Lisp things are called S expressions. It means symbolic expressions. Anyways, if we would write English sentences with these, then you could turn your English sentences into a tree. It'd be very easy. I would do this. Okay, like I cars. Wait, no, I need a parenthesis around cars, and then we do red, right? You do this, and
Yeah.
you know exactly what tree this English is. I missed a parentheses, but
Yeah. Like,
right, but yeah. So you can tell exactly what tree we're dealing with, even though it's English language.
mhm.
Um, so English is like a very bad programming language where it's very hard to figure out what tree you're talking about.
Mhm.
English is
Okay.
worse than any of the programming languages. Like, it's a lot easier to go from PHP or Java to a tree than from English to a tree.
What about the brain?
The brain?
Yeah, your mind.
Oh, how does that work? I don't fucking know. That's complicated.
I'm assuming it's a much worse programming language than even English.
Oh, I don't know. It's no, that's hard to say. Like we just have like neurons and it might be like really simple.
Oh.
And there's just lots of it, kind of.
Mm-hmm. Okay. All
Anyway,
right.
yeah,
So
so
like you come
turning
with
I
a.
like red card. Right. Going from this
All
into
right.
the tree is like tricky.
All right.
It's
I
like
think I
it's
might have
not
mixed things
obvious.
up.
Like we have to reorder the words and figure out the groupings.
Okay. I like red cards. Don't have to figure out the words. Wait.
So we
I
have to
don't quite understand.
change the order of the words in order to make it into a tree. So that's like a
Yeah.
bad sign.
Hmm.
So
All right.
PHP is sort of like English. It's like in the middle between English and Lisp.
PHP in the middle between English and Lisp.
Like harder to make a tree out of, but it's not as bad as like a random sentence from the fabric of reality.
How hard would it be to get English to become a better language?
Really hard.
Ah.
But what you can do is you can like supplement your English with trees when you're having communication problems.
Mhm.
You can give like extra hints and stuff. And you can draw pictures, you can
Okay.
you
So
can be
like
like, here's the English
English.
version, and then here's some extra information that'll maybe help because English is hard sometimes.
Okay. So English. Trying to use your tradition thing. It has like hundreds of thousands of hours of like thought put into it, and it's been like edited for like hundreds of years. So
Yeah,
like
English
it's still pretty
has
good.
there's good things about it. Like people have put work into they found things that sucked about it and made them better, and they found things that were missing and they added them. And they've done this over and over for a long time. Like most of English is pretty useful, and there's actual reasons it's there. So it's not easy to just like remake it or something. And Max, I don't know about that. So there's a reason that the brain might be elegant, which is that evolution is a pretty efficient programmer. Like it can intelligence is written with a fairly low amount of data or like code. But it seems like there's something reasonably efficient or elegant going on there. And they kind of need that because they have trouble like making the brain bigger. They can't just throw more hardware at it because of getting the brain out of the vagina is a problem, for example. So I think there were selection pressures to make it efficient in some ways, which can lead to elegance and good design. Not like it doesn't 100% have to, and it might be weird, but there's convergence between like efficiency and good design in general, and simplicity. And efficiency is the one that's like most clearly evident in our evolved brains, I think. No, stuff you don't get stuff for free. If stuff doesn't have an active benefit, it fades out of the gene pool because random mutations on it aren't selected against. So there needs to be an active benefit to stuff, or it just dies to mutations over time.
Yeah, I don't quite understand how that works with evolution. I'm guessing I don't really understand how evolution works. I'm pretty sure it's a thing where a lot of people feel like they understand it but don't.
That is definitely
I
true. Yeah.
so like I might not really understand it much to begin with.
Okay, well,
But
for genes, oh, Max, you think there's like an error correcting code in the genes? So like even if it's not useful, the like error correcting code makes it stay or something? I guess that could make sense, sort of. I don't know. I haven't thought about it enough. Anyway, internet. So animals randomly change,
yeah,
and then some of them like have more kids and live longer and stuff. And so
yeah,
when they have those ones have more babies. So like the ones with that are designed better have more babies, so then there are like more of them in the future. There's like this bias over time towards the ones that are designed better for having more babies.
yeah. So like, okay, don't
So
quite. Okay, I think I
So if
understand.
like having two hands is better than having one hand, then the ones with two hands are going to have way more babies, and then there will exist more babies with two hands because
Hmm.
your babies usually have the same number of hands as you.
Yeah,
And then the ones with one hand will die out of the population, and everyone will have two hands. And so that's two hands as a positive trait. It gives you an advantage. It helps you survive. And one hand is a negative trait that like makes you at a disadvantage.
Yeah.
And
It's
then
not like the two-hand people are like killing the one-hand people. It's just like
right,
two hands are like better. So like if there's a
yes,
choice between two hands and one
the
hand,
one-handed people
then
are
like
less successful at hunting and gathering.
yeah, like the two hands will thrive more, and that kind of just like if you imagine it like a pie chart, it's like the two hands maybe start out as like just one person, and then it like gradually grows and like covers everything because it's like just better.
Yeah. So the thing we were talking about was a trait that's not good or bad. It's like it's not really doing anything important, but it's not hurting anything. And the general rule of thumb, usually, in that case, is it will go away over time because there's random change. Because copying, like having babies, isn't perfect. So there's random change. And when random change hits a bad trait, that is a good thing. When random change hits a good trait, that is a bad thing. And so, like, if random change gets rid of a bad trait, you're going to be more likely to survive. So bad traits get selected against. And if random change creates a good trait, you're going to be more likely to survive. And if random trait change gets rid of a good trait, you're more likely to die. But what about a neutral trait that doesn't really matter one way or the other? Well, then, if random change changes it, you're not going to be selected against. Like, there will be no penalty for losing it in general. So what happens over time is it just randomly like goes away because there's nothing maintaining it or causing it not to get changed. It's called genetic drift, I think, when things just like randomly change around without any purpose to it. I've not read what Max was saying yet. Okay, possibly error correcting code, but more distributed. Oh yeah, so like opcodes that are just stuck there because they're in use in some way, like their legacy code, like you could code it a different way, but you currently are using them, something like that. So there's a dependency for active code. Yeah, could be something like that. But there is some selection pressure against that because uh like data capacity and number of opcodes and whatever are all finite and limited, and there's actual pressure to use them well, get benefit from them. So I would expect our code not to be like too bad. I don't know, I think maybe it depends. I think it can work well at somewhat higher levels sometimes. But also in particular for the like intelligence and mind stuff, um, there have been estimates of things like how much of the human genome is different than a monkey or an ape or whatever, right? And then you can look at how much data that is and be like, well, that's not all that much data. That's less than Visual Studio or whatever. And then you're like, okay, I guess evolution seems kind of efficient compared to current human programmers. So I don't know like details of that and haven't really studied it, but from what I've seen, it looks like the actual evidence is that our code is like reasonably efficient. Yeah, but if yeah, there is the underlining library functions that are shared with apes and whatever. But the fact that those would support intelligence being a reasonably short program, either means intelligence itself is really efficiently done, or that those other things are like well designed and actually do a good job of enabling higher level functions built on top of them. Like the library functions must have reach if they're what's enabling intelligence to be written quickly. So that would show something about good design and efficiency and elegance and whatever. if our intelligence was layered on top of like a really really shitty underlying language and set of libraries, then it would likely be like a lot of code because it would need like a large translation layer to get to something decent, or it would just have to be really convoluted. But yeah, this is all fairly speculative. We don't have the details. Yeah, sure, and right, I agree. And also, our brains, like neurons and whatever, have a similar length of selection pressure, I guess. I don't know exactly the numbers, but it's very old to have brains with neurons. So I'd expect something reasonably good there. Wait, old? What? I was just saying that neurons are very old. Like a neuron-based brain is an old thing. That's had a lot of evolution time to get it working well. Evolution, for whatever reason, it's hard to fully understand why, but it seems to be pretty good at hitting on good designs, like DNA and RNA and cells and so on. Like there's some very good design work in some of those things. And like the double helix spiral thing with the error correcting and cells as like a modular unit of design that you can like fit many of to make a person. Um, those are like indications that evolution is biological evolution manages to hit on good design. I assume the reason has to do with reach and like the connection between success and things that work. Like in general, if it works well in 3 cases, then often because of reach it'll work well in like many cases. And evolutionary success, I think there would be selection pressures for designs to work well in 3 cases rather than only one. Like that seems advantageous. So I think that gives an advantage to at least a little bit of generality. I think when a little bit of generality is advantaged, you get these jumps to lots of generality. I think that's the general principle of why evolution is a good designer, but it's definitely not an area where we're very precise. We just have some overview ideas about why it works.
Oh yeah, so you could like put an ant like on any substance or like any material and it could like still navigate.
Yeah, that's an example of reach. Um, yeah, an animal can be on many different materials, and then its legs still work, and its ability to walk around still works.
And
So
it
there's
still has
some
like
general
good pathfinding.
purposeness to its pathfinding and its walking and its legs themselves and so on.
And it can like spot a pothole and like walk over that. Even if you're like on a different material, even if it's like between like two things which look exactly the same and then there's a hole, it can like still spot that.
Yeah, so there's some very general purpose deep concepts involved there, like solids versus liquids versus gases. And so walking has reached to solids, but not liquids and gases. And then there's things like the shape independent of the material. So like it can walk on a flat shape regardless of which material is making up the flat shape. And it can walk on a flat shape with some small holes in it, regardless of what the material is, and so on.
I think I remember hearing something about human muscles being pretty efficient at moving stuff.
That sounds plausible. I don't know about it. I've heard that bikes are very, very, very efficient design. In a semi-related note.
Oh yeah, it's like gears are really efficient, I think. I like quickly
Oh
looked
yeah,
at
gears
something
are
on
good, but
Wikipedia.
you can have a bike that can't change gears, and it's still an efficient design. Like the way that your feet go in a circle is a good way of like getting work out of your muscles efficiently.
Mhm. Yeah, I guess like if you're running or something, a lot of the force is going into the ground instead of like creating momentum for you. It's like the amount of energy being turned into heat isn't too much compared to like how much you're outputting, but you're also outputting a lot in the wrong direction. But like with a bike, I guess it would be like very little heat and a lot of energy in the place you want it to be.
Yeah, that seems to work pretty well. That's why there are those kind of generally dumb schemes to hook a bike up to a power generator. They're like, this will be the most efficient way to get power from human muscles. We'll have someone on a bike hooked up to a generator. I was like, okay, not the worst idea, but way too hard. Let's use horses or coal or nuclear or something.
Yeah. I understand stuff like that if it's like a kind of off the grid thing. Like, what if you're in Antarctica, but you still want to work out? That would make like a lot of sense.
Life is not that inefficient. Like it depends on the scale. Like how inefficient is inefficient? Like is if you have if you lose like 50% of the energy, like you could say, oh, that's inefficient. We lost half, but you could also say, a lot of other processes would lose a lot more. Maybe that's good. Right, like if you're growing like cows as meat, you do have a major energy loss. However, when you run like a coal power plant, there's also a major energy loss of like the theoretical chemical energy in the coal. I don't know what the conversion rate is, but I know that like all of the ways of getting energy have major loss factors. I don't know exactly how they compare. Nuclear, I assume, is especially inefficient, that it's dealing with like such a powerful, efficient source of lots and lots of energy that it's okay to have a bad efficiency factor.
Oh yeah, so something has like 10,000
Oh
energy
yeah,
in
right.
it.
So they make it deliberately inefficient because they don't want it to blow up. They have to like control it and not let too much energy out.
Uh,
I think that's what Max is saying. I don't know exactly. I know that the basic idea is you take the energy and you put it into water, and the water makes steam, and the
uh,
steam like spins some wheels or something, and then you get the energy from that. Um, so you have to be careful to like not vaporize all your water. So they try to control the reaction rate.
yeah. Sounds like a
But I
thing
what I
that
don't
could be
know is how
fixed.
much they're just like delaying the generation of energy. So they're like, we'll just generate like only this much right now and more later, versus how much is actually getting wasted as like waste heat or something. So I would say if you're like not actually using up the fuel source, you're just slowing it down to use it up later. That's like not inefficient in the same way as a bunch of waste heat getting out. But they definitely have to slow down the energy release compared to an atom bomb. %99 is wasted of the uranium, so we're losing a lot of the fuel. Okay. But I guess so a lot of that is not waste heat, it's just we're leaving the energy in the fuel. We're like it's like we're not using all of the fuel up. That makes sense. Whereas like with coal, maybe there's more waste heat when we burn coal, and we're not leaving as much chemical energy in the leftover ashes. Maybe we'll dig it up eventually. Maybe we'll just use like fusion or something instead and not really care.
I like how Alex Epstein talks about mechanical muscle, and I'm pretty sure he's talked about like how great and important and good it is.
Sorry, I missed some of the words. Mechanical muscle? What?
Alex Epstein talks about that a lot and like emphasizes its importance. I think that's good.
The importance of machine energy industry
Yeah, like
as
uh
opposed to manual labor?
yeah, like as opposed to like
Yeah.
using human muscle.
Yeah.
Like a
No,
car.
making humans like do all the lifting and carrying and supply all the energy is like really, really bad compared to having like machines and
Yeah. There's also
factors
something
and power and
yeah. People okay. Something with socialists, I forget exactly what, but they like don't value labor saving devices. Like they say alright, it's what? Siri, no.
yeah, some of the people are worried that like there won't be enough jobs if the machines do too good a job, which is really confused.
Yeah. Like
And some
everyone
of the
just
people don't respect like they dislike leisure time and luxuries in a way, and they sort of want people to have to work hard and not think too much.
hmm.
I saw, I think it was in the Black Lives Matter stuff. Someone said like make a CEO break up rocks for 12 hours a day every day for a few years, and now he's working class. It's like you're right. If you make someone do hard labor all day every day, you will fucking break their mind and break their spirit, and they're gonna be working class idiot and no longer a thinker. So let's not do that though.
Hmm.
But they were in favor. You're missing one message? Me?
Oh, it's an image he linked.
Oh, I'm going to Discord now. One of the messages did not appear because YouTube hates us. Got it. Yeah, I got a nice praise comment on one of my videos the other day. And then I was considering replying to it, and then I just didn't see it on the page. And I was like, oh, YouTube put it in likely spam without even telling me. On the other hand, I got like 6 flame comments. I didn't even check, but I wonder if any of those went in likely spam or not. Let's see. YouTube Studio. Where's my Discord? Japanese people are sometimes employed to cut grass with scissors. Or were at one stage. Oh, I see. I guess YouTube thought you were racist against Japanese people and you want them to be day laborers who do who clean toilets with toothbrushes and cut grass with scissors. Why are you such an awful person?
Okay.
Oh, here we go. Yeah, this will give you an idea of YouTube's algorithm. They couldn't figure out that wannabe friends is actually spam. I'm gonna fucking report that one. That's actually a spam bot.
Oh yeah, I remember. Like you saw the video. Or wait.
Yeah, there was some
Upper
video about
Echelon
how there was like
Gamers.
mass spam from some accounts. I forget who made it, but this is one of those. This is fucking spam.
Wait. Are you looking at? Wait. I went backwards in the fucking live stream. Oops.
Right, and then
Steven.
so here are me getting flamed 1, 2, 3, 4, 5, 6, 6 times, 6 flames in a row, literally 6. This is the guy who came into my my live stream and said, "Oh, it's Cringe Lord Curi or something." Right, so he's saying things like, "Jesus Christ, you watch The Rebel," and "Proud Boys." Like these are terms that could be flagged by algorithms. He's calling me a smooth brain. He's mentioning Antifa and fascist. Police, trustable, smooth brain, Antifa, InfoWars. He said fucking InfoWars and he got through the spam filter. Oh, and then to top it all off, to go with all his other comments, quote, "Your bias is obvious." Right, so none of this got filtered. I'll show you what got filtered. Where is it? It's the other one from Anonymous Molecule. Where the fuck did it go? Wait, is it not here? Did YouTube do something to it? I went and manually approved it. It's not even showing up. Oh well, let me just find one of his other comments. Okay, God bless, I believe, is on the same video. Here we go.
That was the door.
Look at this. This shit was not even showing up in my YouTube Studio comment thing. It's not deleted, it's here. It just wasn't showing up. YouTube's fucking awful. Anyways, this one was the one that was held as likely spam. The one that starts out "great video, thank you" is likely spam. But then also has a bunch of words and isn't just super generic. Like, the computer can tell that this is not... Oh, did I not go far enough back? Wait, where's the one that said "God bless"? Because I thought it was from the same day. Wait, where's "God bless"? Oh, there it is. 4 days ago. Right, I got back to "God bless," so I think I went far enough. Here's "God bless," 4 days. Here's 2 weeks. So it should be above this one. No, here's 2 weeks. It's showing plenty. Here's a month. It's not even showing my own comment replying to that guy. Publish. Wait, is there... Yeah, I don't know. It just won't show up the comment. Anyways, yeah, great video. Thank you for this attempt at exposing that channel. He doesn't even name the channel. It's obviously not a spam bot. Great video. Thank you for exposing this channel. His channel is not at all philosophical, and there's an obvious bias in his political ideology, and is very unclear on where exactly he stands on any particular topic. He fails to explain where he believes the line should be drawn, and which brings into question his own personal moral philosophies on what is acceptable and what isn't. Thanks again for being the first video I found that exposes what exactly it is he's promoting on his channel, #curi. Like, how the hell does this get filtered? But God bless is fine. Jesus Christ, you watch The Rebel is fine. Let's be friends is fine. Possibly mentally ill is fine. But the one like long comment that explains something and was positive gets filtered? I of course wrote YouTube hates us in my reply comment that isn't showing up in the admin area. It's conceivable that length is a trigger, but I'm skeptical. I've had long comments before, like Evan O'Leary and Alan had like a really long discussion. Here's a semi-long one from Evan. But if we go further back, here's like a long comment. Like this didn't get filtered, pretty sure. Wait, what? Oh, this dude. I was on a different video. What? Did it show up at some point? I don't know what Max is saying. Molecule? Those are the only ones that have molecule. Here's a longer comment. I do get long comments sometimes. They don't all, they definitely not all the long comments get deleted. YouTube's awful. Did you see my videos on how Google de-ranks pages like completely just out of the rankings, like super deboosted so you can't find it at all? If you link to a recent Project Veritas video, you can troll other people's blogs or any like public site. Like you can go in someone's blog comments and post a link to a Veritas video and then get their entire blog post hidden from Google, at least for a while. I think it might only be for like new Veritas videos temporarily, but it's so evil and abusable. Like seriously, if you're trying to out search rank someone, you can like go to your enemy and just like post like, you might like this Veritas video, I think it's really good. And they'll be like, oh, I have a fan who's trying to recommend good content to me. And it's like, nope, I tricked you, and now your page is deranked.
Huh. I hope you're not giving Andy ideas.
There's an I haven't responded filter, yeah. Oh, was I filtered? The filter was on by default, is that what happened? Because that's a fucking terrible default. Oh, I thought it was like an option I could click on. But it was an existing filter. Oh yeah, here's the comments, they show up now. Okay, so this particular thing wasn't nefarious, it was just bad UI. Or UX. No, I totally saw you say something like that, I just didn't understand what you meant. See, I read this and I'm like, oh yeah, there's a filter option. That's not going to help me. I don't need to use that filter. Why are you saying this? I didn't realize you were saying that it was enabled by default already. No, I was looking at all the comments. I was just a bit confused about what you were saying. Yeah, hearts are also confusing. Okay, anyways, so next time we could look at grammar trees in more detail, maybe. I think those are pretty useful. If you learn some grammar, it helps.
Yeah, I'm
But
pretty not understanding of grammar. I have like not too my limit's like noun and adjective, and I'm not very sure that I'm good at knowing what those are.
Okay, yeah. So grammar is pretty useful and important in my opinion. A lot of people like sort of dismiss it and they're like, I can read, it's fine. They're
That'd be
also like,
because
oh, grammar's for like school kids. I'm not gonna learn that.
okay. The reason they don't think it's important is because they have like things internalized, but they can't like explicitly say what the grammar is, I think. Otherwise,
Yeah. The
like
thing
they're using
is,
some rule set for reading.
yes. Yeah. They like have a bunch of intuitions about grammar, but the thing is that sometimes they're wrong, and sometimes other people are wrong, but they can't explain it because they don't know how it works. They just say, oh, well, obviously it's this way. And so sometimes you're wrong and no one can explain it to you because you don't know why you're wrong. You don't know what your thought process is. So, like, you can't, regardless of whether you're wrong or the other guy's wrong, if you can't explain your thinking, you're not going to be able to communicate about it and figure out who's wrong and why and correct the error. So that's why their poor grammar is a problem. And they definitely make errors sometimes, even if, like, they're often correct. So if you learn how it actually works and you're able to, like, say it in words and think about it consciously, then you can actually discuss things when there's a disagreement instead of just getting stuck. So that's better. I haven't been able to convince people of that very well, though.
Okay. So,
But yeah, on the other hand, we got like halfway to learning basic programming stuff already
yeah.
by accident.
Programming stuff was pretty fun. I especially liked that part, I think.
Most programmers don't even know that their code is getting translated into a tree or like how trees work. See? It's people think that's like too advanced, so they don't even try to teach it to most of the programmers, I think. They don't really understand what they're doing in a conceptual way. They just know a bunch of like specific details about how to use some programming tools. But it's kind of sad that they don't really understand what they're doing very well. And a lot of people, even who are even professional programmers, they have trouble learning Lisp syntax that I taught you. Yeah, the S expressions. Where you have nested parentheses that equal trees.
Uh, they have
Yeah,
trouble
that thing
learning.
you've learned, that puts you ahead of a lot of programmers.
Huh. That seems bad. That
People have trouble
that's the
learning things.
standard.
I've said a lot of times that the world is inadequate and there's like a desperate need for more brain power. And some of the
Hmm.
things aren't super hard. People are just really, really like anti-learning or something.
Hmm.
It's like this is not fucking rocket science right here. And
Yeah.
nevertheless, like so many people complain so much about it and never really learn it or understand it.
Yeah. Uh. Damn. Uh.
Yeah, and then those same people can write this. HTML body or head blah blah head body blah body uh those same people who can't fucking understand Lisp can write this though.
Hmm. Hmm. Okay. Don't really understand what's happening there.
Yep, but I will show it to you. This is not very hard. Okay.
Okay.
First I'm going to hit enter and tab. Then I'm going to hit enter. Then I'm going to hit enter and delete. So that might have helped a bit.
Are these... Okay, HTML. So we're doing something under the category of HTML. Oh, slash HTML. That's like ending HTML. So we're starting
Yep.
HTML, head, so that... Okay, I don't know what HTML is, so I don't really know what head means in reference to it. It has something to do with
HTML is the
websites.
language that websites are written in, web pages.
Okay, so like the head of the website says blah blah, and
Yep.
like we end the head, and then the body of the website says blah blah, end head, and HTML.
Yep.
I mean end body and HTML.
Yep. So this right here that I've highlighted, the HTML thing in angle brackets, it is a named open parentheses. So it has two features at once. It is open parentheses plus we're attaching a name to it.
Open parentheses. Oh shit! So like it's open parentheses and then it's closed when you type the slash. Is that it?
Yes, the one with the slash means close the parentheses for that name.
Ah, okay. I've seen this as well with like some things. Like sometimes you can do like bracket I close bracket, then like at the end of it you do like bracket slash I
Oh yeah, that's
close bracket.
italics. That is HTML text. Yeah, that's how you write italics in HTML.
Yeah, so that's like italics, but with like parentheses.
Yeah, now here's the same fucking thing in Lisp. You just use the name as the operator, and the inner stuff is the data. Or if there's multiple inner things, you can put a list. Like, word 1. No, A, E, blah, blah. You know, something like this.
Okay, so let's see how does this work. The main first tree thing is italics. Then what's the next thing we're doing? Okay, italics is like the only tree thing. Like it is A and B and blah. They're all siblings of each other. I don't know what A, B, blah is doing.
Those are just data. They're like words.
Ah, okay. And so they're the data under italics. Oh. Oh, right. Italics is italicizing them.
Yeah. Okay, and here's the HTML one as Lisp.
The HTML one. That seems way nicer.
I agree with you. They're
What
like, oh my god, there's too many parentheses, and I'm like,
you don't have
you
to
write
type HTML
you
again.
write angle bracket, open angle bracket slash HTML close angle bracket, and you're like, this is so much better than one close parentheses. Like, even if you just look at the first line, we have an open parentheses in HTML. This is less stuff than this, right? We saved ourselves a close angle bracket.
You have to start head, then end head, start body, then specifically type like end body, and then also specifically end HTML.
Uh-huh.
The way you end those in Lisp is you just put a fucking parentheses at the end.
Uh-huh. Yep. You don't need to say which thing you're ending because you're always ending the most recent thing. And if it's confusing, here's what you do. You write end of head. You just write a code comment if you need to explain something. That's how you do it. I do this in Ruby sometimes because you'll have long things and then Ruby uses, instead of close parentheses, Ruby frequently uses the word end. It's just END. Yeah, that's true, Max. You can do it with white space. I like the parentheses, but whatever. Anyways.
Just typing end seems a lot better than like typing slash HTML end slash head end slash body end.
Yep.
Like still not as good as parentheses.
Yeah, Ruby is more word based. But anyway, it's a design thing. It's not a big deal.
Okay.
But the point is, you'll get these long, complicated things, and then you'll have the end statement, and you'll be like, well, what is this ending? It's not obvious, right? So there's like kind of an advantage to having slash HTML, so you like know what's ending. However, I just write like Ruby thing blah, 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 blah. And there will be like 5 ends in a row sometimes because you did like lots of things.
Yeah.
So all you do in Ruby is you go like this. This ends the loop about teachers. And you go like this ends the function. The Ruby thing function. And like this ends the grading part. You know? You just write
Yeah.
comments on them if you need to explain them. Like it's not a big deal.
Okay, so I don't really know what elegant means, but comparing Ruby to HTML, Ruby looks. I don't know. Ruby to the other coding thing, which I don't know what it is, but it looks terrible and ugly. Uh, Lisp. Lisp to other coding thing, which looks
Lisp
terrible and
versus
ugly.
HTML? Yep.
Yeah.
Yeah. But don't worry, HTML has a special case, because you can go uh like go width equal 50, style equal blue. They have this extra feature where you can like add extra things in with like a different syntax. This is an example of like different ways of writing information. They're like, you can have the information be the name of the name of the parentheses, or you can have it be in between the parentheses, or you can have it in these extra attribute things that are attached to the parentheses. So they have like 3 different things instead of one thing. And Lisp is like, we only need one thing. Like Lisp, you're just like, you just make the body take a text and then an options list, and in the options list, you give it pairs like width 50, and you give it a style blue pair, and now you've given it a list of options along with your blah blah text, and you've managed to do the same thing without a new syntax where you write attribute equal value after tags before the angle bracket closes.
Okay.
Like Lisp doesn't need to invent a new thing to do this, but HTML just like makes up multiple different things for some reason.
And anything to do this, but
And
HTML
with
just makes
Lisp, we're like, we can already do that using parentheses and operators and data, and we don't need other things than those 3.
operators data. Okay, so you're using parentheses, operators, and data, and HTML was like, we're gonna add some more shit.
Yeah, this is
So what
this is
was
like a different thing than the other things. Like it's an extra
okay?
feature that you have to deal with in a different way.
Width equals 50. Okay, I don't quite understand what's happening in HTML versus, or wait. So what
They're
is
saying that
HTML?
the body, which is like the
Yeah,
main
body,
text area, has a width,
body.
and we're setting the width to 50, and it has a style, which we're setting to blue. So they're giving like
Okay,
extra info about the body.
okay. About the body. And then Lisp, what are we doing? We're like saying it has a width that's 50 and style blue.
Yes, we're
Like I
just
don't think I.
passing in the information as extra data. This is additional data. We're just giving
Mhm.
a list of
Ah,
options, a list of extra data, and then the
mhm.
first one is a pair, which is the option we're setting and then the value, and then the second one is another pair, which is the option we're setting and then the value. I shouldn't have commas. Lisp doesn't need commas. Oh, do you know why they use commas all the time? This is stupid,
Why?
but so all the programming languages are like do thing X, Y, Z. This is how they call functions. I was showing you their functions earlier, where the
Like,
open parenthesis comes
why?
after the name of the function instead of before.
Open parenthesis comes after. Okay. Uh, wait. Was I following? I don't think I was following.
We
Uh,
went over these earlier. Where are they? Like this add 3
okay. Add 3. Yeah, we have
or
add 3
purple.
data 7. It's like we add 3 to the data 7, and that will give us 10.
Yeah. Okay, so do thing is like add 3. It does something. And it
Okay,
takes
do
these
thing.
inputs, X,
Add
Y, and
3.
Z.
Mm-hmm.
Okay,
Yeah.
so the interesting thing here is that they have commas. So why do they have commas? In Lisp, you don't need commas. You just do thing X, Y, Z, right?
Okay, so let's think about this.
You
You
probably
should be
won't get
able
it.
to.
But go ahead.
Yeah,
I'm gonna
I'm
go to
gonna
the
show.
bathroom. BRB.
Okay. Okay, so if it has commas, uh, the program should be able to tell if it's the same number or not. So it can't really be that. It's not like they're going to be confused. Like, if XYZ is 1, 2, 3, it's not going to be like, is this 123? Okay, what else would there be? Uh, okay. Do you need it to, like, tell it what to do? Or you, like, do X, then Y, then Z? No, that seems like would be dumb. Okay. Lisp can just be like, okay, there's X, then Y, then Z, do something to that. Why would you need commas? What can Lisp do that this other thing can't? Hmm. Commas. Okay, it has something to do. Okay, if you could do it without commas, that would be nice. We need the commas for some reason.
Okay, you had it actually backwards. You said what can Lisp do that the other languages can't? But it is the
Yeah.
other way around. It is what can they do that Lisp can't? What extra stupid features did they add that made them need commas?
um, huh. That seems wrong. Uh, I don't know what feature they could have added.
Alright, well, it is infix math. It's not necessarily the only one, but I think this is a lot of the reason. So, suppose that we were doing our do thing, and we wanted to do...
Holy shit. How do you delete to the right?
Well, you can do Lisp with no commas. You just put like a... I mean, I'm used to Scheme, not Lisp. So you just do like A, B, C. You put the apostrophe in front to say it's a Lisp, a list, and yeah, you don't need commas. In general. Maybe like, I don't know, if some specific Lisp dialect uses commas or something. But anyways, where was I? Okay, yeah, so we're do thing, 3 plus 3. Okay, so suppose we were doing infix math like this.
Okay, I suppose we're doing.
So the computer is like, is this one thing or is it three things?
One thing? Or is it three things?
How many things is this?
There are three things. There's two datas and one operator, but that's like three things.
Okay, so let me show you the Lisp version. Plus 3. Oops, I need parentheses. Meant to type one. Okay, there. So in Lisp, how many things is this? It's one group. And you see that because there's parentheses.
There's one group. Yeah. I think okay. So the group is one thing.
Yeah. So in Lisp, it's
Okay.
clear that this is one group. So this is going to be, we're going to give the number 6 into do thing. However, this infix math, they're like, oh, I don't know if this is one thing or like three things. But I think this is part of their problem. Because you can have, see, you have spaces, right? You have spaces in the middle of your math. So they wanted to allow spaces in the middle of the math with no parentheses. And I think that's a lot of why they use commas. So that you, because if you wrote like 1 plus 5, 7 minus 2, and then you look at this and you're like, what the fuck? It's partly visual, and I think it's also partly a problem for the compilers, the computer to figure out. So they're like, how do we fix this? Well, we separate everything with commas because we don't know where they start and end. So they made it confusing about where things started and ended, and then on account of that, they separate everything with commas. Whereas Lisp, you always know where things start and end because there are parentheses where they start and end. Or white space, right? If there's white space, it's a new thing. That's how Lisp works. Whereas they're like, well, you can do infix math with white space mixed in, so we don't know where things start and end, so write commas.
So Lisp can't do infix?
Right. Yeah. Lisp does not do infix.
Okay.
Yeah, Max, you could theoretically do it, but they just, like, don't. It's too hard, or they don't want it, or I don't know. But I think it's a lot of the reason for commas, because I don't know why else they need the commas. It's infix isn't the only thing, but it's just generically they have too many things that are like messy, unclear syntax, so then they just need comma separators.
Let's see. You need comma separators.
And about this apostrophe, this is a quote. It's the same as like quote ABC. What you're doing is you're saying that we're not invoking. If you write this, we're saying call the A function with B and C as data. So this is saying like treat them as words. You could also like explicitly have symbol or string or whatever data types and have ways of specifying them or whatever.
Wait, so how is this saying to use the A function?
Well, if we do this, then Lisp is like, oh, we have an operator and then data, because that's what it always is. That's just the default.
So it's like prefix, so like first thing's operator, then we have data.
Yeah. So if you want to tell it not to do that, you can put an apostrophe in front as a common shortcut, which just means quote. It's saying quote this or make a list of it or whatever.
So this is just like data and also quotes, like make a list of it. Okay, I don't know what the point of doing that is, but I don't think I really need to. It's like make some kind of the list or whatever. Like treats it all as data, not like the first thing's an operator. If you use prefix all the time, then like the first thing would like always be an operator with data. Wait, yeah.
The apostrophe is just a simple macro to the quote, I think, if I remember correctly, and then the quote is a like built-in part of the language. It's one of the like 7 core functions you actually need.
7. That seems like very few functions, core functions. Okay, so and then you can create your.
Lisp does take unknown numbers of arguments. You can just do def foo x. I think you just do like dot y if I remember correctly, and then the one after the dot is and then you can call it with any number of arguments, and it'll make the first one be x, and then it'll take all the other ones and it'll make them into a list, and then it'll put them in y. So y will be a list of whatever number of arguments, 0 to infinity. This stuff isn't super important because you can just like in a language that doesn't have this, you just do this and you tell the user pass in a list as the second argument, and then they do that and it works okay too. It's the same thing as like having multiple return values. Doesn't really matter because you can just return a list of multiple things if you need to. It's the same thing with multiple inputs in general. Like you could have all functions take one input and just have the input be a list. So not a big deal. I'm having trouble reading this thing here. Like backtick dot backtick dot. I haven't read all the above though. Oh, that dot thing is just a special syntax, yeah. I think that's the syntax, but I might misremember. But there's just some syntax that says this last argument takes all the remaining arguments as a list.
Yes. Remaining list. I don't really follow with what this dot is doing. If there was no dot, then I think the x and y were just like, or I think the x
Yeah,
is an
the dot
operator
is
and the
just
y is
saying
the
that the y
data.
is special.
Y is special.
So y can be any number of numbers. It can be zero numbers, or it can be one number, or it can be two numbers, or three. You can give as many numbers as you want.
Mm-hmm.
And then the function just receives a list of numbers. So it could be a list of any number of numbers, and that's what y will be.
Function. Right.
So this means that when you call your foo function, you can give different numbers of argument. This is this is obscure stuff that's not super important anyways.
Okay. Okay, but like the dot says that the y is a special case, and it's not just like data or whatever. I mean, there's like something special about the y because there's a dot.
Yes. It's just saying
Okay.
the last argument is special and it takes a variable number of inputs.
Variable numbers. So you could have like,
Like
no,
how
wait,
we talked about having a plus function that takes any number of numbers.
yeah, like with prefix you
So
can just
like
have a plus, and then like you could have a
yeah,
thousand
you do
numbers. You
that,
could
you
have
do this.
like 1 through 1,000 if you wanted.
So this is how you do that in Lisp. You define plus, and then its inputs is numbers, but you put the dot in front to
Input.
tell it that it can be any number of numbers, as opposed to a regular function where you take like x, y, z, and then it always has to have three inputs. This is saying it can have a variable amount of input.
Okay, so if I wanted to like make an online calculator or something, or if I wanted something where like I could put in multiple inputs, then this would be good. Like maybe I want 2 numbers, or maybe I want 1,000 numbers. If I do that, then it will
Yep.
like work with any number. So what's a def? Is that like a function?
Oh yeah, def is short for define, which is for defining a function.
Oh,
Or
so are we defining plus?
yes, I was defining a function named plus that takes some number of numbers and then adds them up. And I didn't write the adding code.
Okay. Def plus it takes any number of numbers.
There are different ways of doing this stuff. In Ruby, um, Ruby has default arguments. You do like def foo x equal 1, y equal 2. You can do
Okay.
this in Ruby. And what this does is they can give you an x argument, but if they don't give you one, you just assume x is 2. And they can give you a y argument, but if they don't give it to you, you can assume it's 2. Like they can set it to whatever they want, but if they don't set it, then you have a default. And one of the things you can do is then do options equal this. And this lets you pass in an options hash, which internet, you don't know what those are, but
No.
hashes let you have key value pairs where you say like a key value pair is there's like a name, which is the key, and then the value that's attached to it. So you're saying like cat equal 3, dog equal 4. These are key value pairs. Cat is a key, and then 3 is a value. Dog is key, 4 is value.
Okay, so I don't think this is saying we have like 3 cats. I think it's saying it's like cat is the value number of 3. So like maybe do cat first
Yeah, I
instead of
mean
dog.
it's not actually clear what it means. Like you could have it mean whatever you wanted.
Okay, so it's
It's
just like,
just we have cat and then we've attached number 3 to it. So if you say I want to look up cat, then the system will come back and say, "Oh, I've looked it up for you. It's 3." Then you say I want to look up dog and it says, "Oh, I've looked it up for you. It's 4."
so
And then
this
you
might,
can save numbers attached to names. And they don't have to be numbers. You could save different things. And the keys could be numbers or anything as well. Like you could say key is 4, and then we're going to attach 45 to it. So you're like, look up 4, and they're like, oh, it's 45.
hmm.
Which is a little strange, but you can do it. Anyways,
Alright, so if you look up dog, it would also give you 45?
no.
Oh.
Nope, dog would still give you 4.
Huh.
It wouldn't chain the lookups together. I see why you got that, but this particular system doesn't work that way. They're separate. Anyways, the point I wanted to tell Max is what you do in Ruby all the time is you have an options hash that's optional. And so if the user doesn't supply it, you just get a blank hash where everything is nil. And then if you do supply options, you can supply whatever you want as options, which is essentially adding named arguments to your function call. And then you can have a variable number of named arguments attached to your function. That are all optional. Do you think it's a bad habit? I find it generally pretty useful. What do you recommend instead? Oh, it screws static analysis type stuff? That makes sense. Yeah, the Ruby and Python communities don't care about analysis anyways, from what I've seen, so... Rails does this all the fucking time. And it's reasonably convenient. Especially because Ruby doesn't take variable numbers of arguments. So they do this instead. Rails has a lot of like hacky and magical stuff. There's definitely design flaws. There could easily be a better way of doing this particular pattern, but I don't know what it is offhand. And I do see the upside of this. I don't know that Python should have type annotations. Like, my general opinion is it shouldn't really try to be fast. It's a scripting language. It should stick to, like, what it's good at. I mean, maybe there's reasons to add it, maybe it's okay, but, like, if you actually want it to be fast, maybe you should use a different language. Oh, it's not done for speed, it's done to... as a type of bug checking? I see. That seems pretty tacked on for Python. Like, Python isn't designed for that type of analysis and bug checking. That was not part of the original design. If you want that, you should probably use a different language. But maybe it's worth trying to add to Python at this point? I don't know. But like, if people really care about that, just learn a different language. And build it in a elegant way from the start. Are people adding these to existing code bases or something? Yeah, I guess. Yeah, if it's deployed widely enough, I guess that's a reason to do it. I don't know how much you actually want to add the annotations to existing code bases instead of, say, adding a bunch of unit tests or asserts or something. Like how useful that is. It's worth all the effort. Because I'm kind of inclined to say that Python and Ruby and whatever should just stick to what they're good at and focus on being good at it instead of trying to fit in with these other themes that aren't their thing. Always optional can still have effects on the language. Like it can affect language design and future features added and the difficulty of writing the compiler and stuff. So it can end up being a constraint and causing trouble in some ways for the community. I don't know how much trouble this particular thing causes. Won't break too much. Okay, so it sounds like maybe it's a reasonable compromise. Oh, they're only for the IDE to check things, not the compiler? Oh, I was totally thinking it would be a compiler feature. Tacking it on at the IDE level is a lot less intrusive. Or I shouldn't say compiler because it's Python, so interpreter. Or I guess Python you can compile to bytecode that the interpreter interprets faster. But yeah, basically interpreter instead of compiler. Oh, the interpreter can check it when it first reads the file, and sometimes it will know there are errors, but not consistently. And that's not too hard to do. That makes sense. Automated correctness checking type stuff, like you were mentioning, is something I don't know much about, but it sounds good and useful. Type checking, though, I have issues with on principle, because what you often want is, okay, so if you're dealing with object-oriented, for example, like Ruby, and what you often want is any object that responds to certain methods, and you don't care what the type is. You don't even care if it's an ancestor of a certain class. If it's a completely different class, but it with no class hierarchy relation, but it implements the same method, then you're happy to take it. So it just has to conform to a certain interface. I guess what you're supposed to do there is like define the abstract interface and then take all the different things, even if they're not related in the class hierarchy, and say that they implement that interface. And then for your type checking, you say check that it implements this interface. Right? Is that how you do it? That would make sense in theory. I'm not very used to this stuff. Because in Ruby we don't specify types and we don't care, and we just call responds to. You just do if my var.responds to foo. You do you just do this in Ruby, shit like this. This is maybe not the most correct, best way to do things. You can do like oh, this is a symbol, so I should put a yeah, if you're gonna inherit, you have to have multiple inheritance. If you're gonna like deal with interfaces via inheritance. Multiple inheritance is one of the ways to do it, but Ruby only has single inheritance. And I'm used to Ruby. What's FP? Like, I'd think functional programming. But I would expect you to have mentioned a specific language there. Oh no, you said functional programming above. I'm not sure exactly what this is. Are you basically just asking if it actually has the type of method you want with the correct type signature? Like, does it have a method with a certain name and a certain type signature? And if so, it's a correct data type? Is it something like that? But if you don't use classes, you're not going to run into a lot of these problems anyways. Because you're going to have fewer types. And they're not going to be organized in the object hierarchies. I don't fully understand, but okay. Anyway, so you see these lines? I was like, I think we're done anyways. It's been like 5 hours. Yeah, I'm planning to stop. After this little programming chat, FYI, you can leave if you want to, Internet. I should have said something earlier.
Yeah, I think we're gonna leave. I want to sleep soon, but I still want to run. Running at 1 a.m. is nice because then there's no one else.
I also have this one, which takes something, and it'll turn like nil-like things, like an empty array or an empty string, into actual nil.
Like, I'm gonna go. Bye.
Bye, Internet. Which is useful because you often have the wrong one, and things that aren't really nil don't work in certain ways, like they're not false. You can do like if you're doing an or afterwards, it can be like my list dot if present or default list. Oh, they added it at a language level? Like, you can just write this function in Ruby because it already has response to built in. Anyway, then you can do this. And if you get a blank list, you will ignore it and use your default list instead of saying, oh, a blank list isn't false. So, yeah. Oh, I forgot. You actually have to use this meta programming. Anyway. Ruby has a send where you can just send a symbol and it will function call that symbol on that object. And it has a response to, which it will check if that object has a function defined on that symbol. Ruby also has object.methods. You can like just literally ask for a list of things that it implements. And you can like traverse, you can ask what object it is and like what its ancestors are and dynamically look through all that crap. But it's it can be kind of messy and hacky. If the question mark I've usually seen as the ternary operator, where you do like foo question mark bar baz. And it's just like if foo is true, it returns bar, otherwise baz. It's just an if else shortcut. I don't know if you're talking about that or something different. So this is like what I think C does this. Ruby might do this, I'm not sure. Ruby does like a lot of everything. There's one of the design principles of Ruby is there's more than one way to do it. They like to implement the same thing like 5 different ways, so you can do it in whatever style you want. Ruby has eval too, so you could do eval, but send is nicer than this shit. Rails does some like meta programming a little bit like Lisp macros, except they have to do it with things like send and eval instead of like actual reasonable to work with stuff. Stuff like eval gets really bad if you use it much. And there's usually ways around it. Like Ruby has functions like instance variable get and instance variable set, and they have this for like class variables and all sorts of other stuff. And they have there's like the def method or something, and you can give it like a foo bar baz, and then you can give it a block. You can give it a code block and actually like define a foo method through a thing. Like instead of doing define foo, you can do this meta programming thing. Oh, I wasn't responding to you using eval. Okay, I don't know exactly what this const the val thing does, but I'm guessing that the basic thing here is only keep chaining the object calls if they're not going to crash, and if they would crash, just ignore them. I assume it does something along those lines. Or maybe it only ignores the specific next one if it would crash. But it's basically like, you know, don't call the trim function if you got a nil instead of a string or something like that. This is a very common case you run into. Like trim it if it's a string, otherwise leave it alone. Yeah, that's a common design pattern. There's probably better ways to do things, so this problem doesn't even come up very much, if at all. But in practice with current programming styles, it comes up quite a bit. Yeah, this makes sense here. That does not surprise me. I learned functional programming early on, specifically from structure and interpretation of computer programs, but I don't have a ton of experience using it. There was a really nice video today though. They found a huge glitch in the newest Zelda, another one, and like many of the previous ones, it is very obviously related to mutable state. And I like to watch glitch videos and think about how much of the problem is mutable state. Because it frequently is things like we set this variable and then we assumed that it would get set to this other thing in the future or would never get set to this or whatever, and they just like assume their variables are right, and you find ways to get the variables set to things other than what the developers intended, and then everything goes to hell. The coding practices that are explained that Nintendo uses that they've discovered in this video are fucking ridiculous. They have all these different shrines in the game, and um they just have this global variable of like, which shrine should I enter? And when you walk near a shrine, they have regions of terrain on the ground, and they're like, when you enter one of these regions, we'll just set the which shrine should I enter variable to the correct shrine. And then when you enter a different region, then you're near a different shrine, and we'll set the variable differently. And then, of course, it doesn't always work, and they knew it didn't always work, apparently because they put in several hacks to try to prevent it from getting broken or going wrong, including one frame out of every second, they do some check. So one of the strategies, but they only do the check when you're on the ground, because, you know, they always do shit like that. So one of the strategies is you can literally just jump at a rhythm so that you're never on the ground at the one frame that they check. And then you just keep walking away until the shrine gets unloaded. And then once it's unloaded, they stop doing the safety checks. And then things are even more broken because you have like a variable set for this shrine that's not even loaded in memory anymore. Yeah, there's definitely ways to stay in the air in this game as well, which is a much easier way than worrying about jumping. There are a variety of ways to stay in the air in this game. You can basically stay in the air without even using a glitch. Um, because there are stamina refill foods, and you have a lot of stamina, and so you can fly your paraglider along the entire map, and someone did that a long time ago. Because fires lift you up, and you can drop bombs while you're paragliding. So when you get near the ground, you just have to be over grass, and you drop a bomb and detonate it, and then that catches the grass on fire, which creates an updraft, so you can gain height again, and you can just do that over and over. And there's a route along the entire map where you can find grass frequently enough. And you actually can have enough stamina to go the entire map when your max stamina bars plus full stamina refill potions for all 60 food slots. I don't know how many you actually need, but this game has been out for a couple years now. There are quite a lot of major glitches. But yeah, this is a shrine wrong warp thing, and the thing they're using it for is to get into shrines that you haven't opened yet. Some shrines you have to do a quest first in order to activate the shrine and be able to enter it. However, you set your shrine entry thing so that it thinks you're entering a shrine. Like, you get it in the state where it's trying to enter a shrine, and then you walk over to a different shrine where you can't trigger the entrance because you haven't done the quest yet. However, when you walk up to that shrine, it sets your what shrine am I near value to that shrine, even though that shrine is not yet available. And then you let the enter shrine function actually execute, and then you enter the shrine that's not yet available. Now, there's no Ganon wrong warp. But there's clipping into shrines that aren't even available yet, like on the tutorial plateau. They started skipping the thing that sets up all the shrines, and they just clip into all of them because they found a mutable state bug with Link's angle while he's jumping in the air, and you glitch yourself so that your angled while you're in the air by using your shield surfing thing and falling off it. So basically you have a skateboard accident while jumping on a tilted, slanted wall, and you get your character at a weird angle, and then you jump into the wall and you use your weird angle to let you clip through it, and that's how you get into shrines early. And then, of course, they didn't bother to have the loading zone disabled before the shrine was enabled. Like, this is a very common theme in Zelda games, going back to certainly Ocarina of Time in, like, 98, is there's all this stuff that will be unloaded, but they leave the loading zones existing in unloaded areas all the time for some reason. So you're like running around in these black areas with no terrain or walls or anything, and then you just get to the right place in the black void, and the loading zone trigger is totally just active. So they totally have that all the time. So you like clip into this shrine that you're not supposed to go to yet, and then the loading zone works fine, and you can just do it. No, it's not a floating point bug. It's mutable state. So your character has like a what angle am I at variable, and you get that thing set in a semi-permanent way to a bad value. Because they forget to unset it when you land on the ground in certain ways. Like basically they're like, when you land on the ground, we'll set your angle back to normal. But if you land on the ground, there's many different ways to land on the ground, and they only made like 9 out of 10 of them reset your angle correctly. So if you land on the ground in the way they forgot about, then your angle doesn't get reset. It's kind of like that. And then your variable is set wrong. And then this is combined with walls being kind of glitchy, not just in Zelda, but in most games. Like they have a hard time not letting people go through walls. So you combine walls being like a bit thin and all the trouble they have, making you not be able to clip through walls, with being able to glitch your angle, and then glitching your angle is enough to get through the very questionably designed walls. Wall design is actually hard. Like so many different games have so much trouble with it. So many games have like weird design flaws. Like they'll write code like, if you get very far into the wall, add a bunch of backwards acceleration. And people are like, okay, cool, now I can use this as a speed boost and like zip across the room by getting stuck in the wall. Like that's the zips in the old Mega Man games. Is you just like fly backwards through walls because they're trying to push you out of the wall, but you're still stuck in the wall, so you get pushed out again and again and again, and then you go really fast. They have all these weird things like that where they knew they had trouble, so they added this like protection code, but they didn't do a very good job with it. Another funny one is in Mario 64, they added a speed limit so you couldn't just go like infinitely fast. So like if you long jump over and over, you will only get up to a certain speed because they literally just put a limit in. But they only put a limit in the positive direction. So you long jump backwards over and over, and then you can get like an infinite amount of backward speed, and then you just go around through stuff by going backwards. Yeah, there's BLJs are not just for parallel universes. You can use them to get through things like walls. You know, if you get your speed fast enough that you can pass a wall in one frame, then in general you can clip through walls. That's how a lot of games work. The concept of like checking the like ray tracing where you're going to go in this frame and seeing if there's a wall there does not seem to be something programmers are very good at. I don't know why they have so much trouble with it, but like none of the games seem to do that shit. Is ray tracing and seeing if it goes through like a rectangle really that hard? Wait, you said hard and then you said easy? I don't know what you're saying. Okay, I see a negative, and then I see empty space. I should think if you have point A of where I am now and point B of where I will end up at the end of the frame given my speed, and then you have some rectangles, like planes that are walls, you ought to be able to send a ray and check if it goes through those particular things, and that math shouldn't be that hard. Well, you don't need complex shapes because you build all of your walls out of rectangles and triangles only, and then you make those you make like lattices out of only rectangles and triangles, or maybe only triangles, and you make those fit the walls well enough. You just use a bunch of small triangles for stairs or door handles. I know some stuff is done kind of like that. Like, I think I've read stuff about graphics cards being designed to handle like millions and millions of triangles. No, the artist people don't have to do anything. You can automate taking their 3D shapes and like triangling them with a good approximation and as much detail as you have performance for. Shouldn't be that hard. But a lot of games are still at the part where you go to a corner that's a bit of a like a tight corner, like, you know, less than 90-degree corner, and then you jump slash into the corner and then you go through the wall. That's how a lot of games still work today. One of the things that makes collision harder is that you have to worry about it's not just one point to one point, it's like the whole character model of the hero. You have to worry about like, is his head going through a door? Is his feet going through a door? So then you're like ray tracing from a bunch of spots, and that can make the performance a lot worse than doing a single ray. They had a bunch of issues with that in Overwatch with line of sight stuff, where eventually they were like, okay, we put like rays on their feet and both of their hands and like both sides of their head, and now the line of sight stuff works a lot better. Like, it's hard to figure out which polygons are in the right region that they might possibly collide. Because like if you look at the entire level, there's like a lot of polygons, so you run into performance problems if you test like every single one, maybe. I know they do stuff like they divide the game world into regions, and then they figure out every single piece of terrain is in a particular region, and then they figure out that the ray trace is going through like only these three regions, and then they only check collision on the polygons in those regions and not the other polygons. And you just pre-compute all of that. You can pre-compute uh like quarter nons or whatever. Is this the thing they use? No, maybe this is the wrong one. There's some name, I forget the technical term, for how you divide up the level into sections, and then it helps you narrow down what parts you have to do collision tests for. Well, that search didn't work. Wait, I saw further. What was this? Further? They're dynamically subdividing a 5D volume into hypercubes? Okay, that sounds fancier than what I was talking about. I know ray tracing is kind of hard in general, but I figure they ought to be able to do like a ray for the protagonist of a single character game, to prevent him from going through walls. That seems like something they ought to be able to accomplish by now. But they really don't seem to have figured it out for most games. Bounding volumes and space subdivision. Yeah, that's the kind of thing I was talking about. I kind of vaguely remember there being something with oct in the name, but it could have been the quarter non thing. I don't know. Oh, down here. I wasn't looking at her. Okay, yeah, so they're proposing some algorithms. I think this kind of stuff should work well enough for single player console games to have better not clipping through walls. But instead, they're just setting things like Link should now enter a shrine, so we'll just try to enter the shrine 1 frame every second and repeat. And also there's a different variable for what shrine should he enter, and if he fails to enter over and over and we walk around for a while, then we just set it to a different shrine and then enter that one. Yeah, I mean, how bad they are does work out okay for speedrunning. A lot of it has to do with their process, like their QA processes. They a lot of their QA is basically, does a regular playthrough work? We'll keep adding band-aids until a normal person doing normal things can get through the game without it crashing, and then we'll say, great, this is a high quality game, AAA, ready to release. That seems to be the industry standard. Like, they just hire normal players, and then they figure if our normal players, testers, got through the game, then probably most of our customers will be happy. You don't have to spend more to do better, though. Like, that's the thing. It's actually, like, cheaper and more efficient to have a good design than to have 5,000 band-aids on top of your game. Like, you could actually work smart instead of hard and save money. Yeah, you do have to actually find some decent coders, and like that's a problem. And so yeah, if you're just gonna work with terrible coders who are gonna have a lot of bugs, then maybe the way they're doing it kind of makes sense. I guess there's that. If you're like management and you just assume that like most of your coders can't really code, then you're certainly not going to do the Ratchet and Clank thing where they wrote a bunch of Lisp tools. Their processes are like, they're ridiculous, some of the stuff they do though. Like so here's one of the stories. Metroid Prime was having trouble with like rooms loading fast enough. And it was causing glitches and stuff. So they went through the entire game and they added doors all over the place. And then what they did is to open a door, you shoot it. And then when you shoot it, it waits like 2 seconds and then it opens. So they just put this artificial delay everywhere. And then their game actually manages to work. It's sort of like a way of pretending they don't have load screens while adding load screens all over the place. But then they do all this other shit. Like they know things are broken, so they'll add like so there are games that have a kill plane under the level. So it's like you shouldn't be able to get there in the first place. But if you do manage to fall through the map out of bounds, they have a kill plane under the level. But then they have a second kill plane under that one in case you miss the first one, because they don't make their kill plane extend infinitely, or they're worried you will somehow fall through it without it triggering. So then it like lower down they put another kill plane. Um, there's a speed run that uses this glitch. The second kill plane though, like teleports you up. So they end up like the fastest way to go up the elevator, it saves like 5 seconds, is you have to fall down, miss the first kill plane, hit the second one, and then you get up warped to the top of the elevator without riding it. Worlds? I don't even know what game that is. Oh, it might have been Outer Worlds. I'm not sure. There's a decent chance that I saw it on the Tomato Anus YouTube channel, and Outer Worlds is one of the speedruns that he did a review of recently, so it could have been that one. And that's the right type of game. Like it's you have like guns and you walk around a 3D world. It's totally the type of game that has that type of bug. So maybe. Do you see the same thing all the time in like World of Warcraft or Mario Odyssey or whatever? They're like, oh, we know someone might jump here and we don't want them to, so we'll put invisible walls. And then they're like, well, what if they get past the invisible walls, so we'll put a kill plane over here. And then after that, people, the speedrunners will be like, well, you just jumped through this spot, which you didn't put a wall or kill plane at, and then you got through. And the devs are like, oh shit. Like they're constantly just making invisible walls and kill planes that aren't big enough to stop the thing they're trying to stop. And it's funny how little control they have over their game, like how autonomous the game is. How much right? Like they set up these general rules like a physics system, and then those physics system has like reach and consequences, like that the character can move around, so the player has this control over the world where he can move. And then they're like, well shit, we didn't want you to move here, but they have trouble finding ways to stop you without breaking the entire system. They Right, that's the problem, because it's easy to stop the player if you're like, well, we're just going to turn physics off. Right, now they're not going to be able to get to the place you don't want. But if you want to have your physics system still work and like still have its generality or universality or whatever, and you don't want to disable that, then what you're doing is you're the one putting band-aids and patches on the player's universality. So like he has this generic power and you're trying to put some obstacles in his way that he won't be able to beat, but you made him so powerful that he ends up beating you a lot. I think that's interesting. It's also interesting just like how much they fail because they didn't bother to make their invisible wall bigger, which isn't very hard. Like if they would just take the size they think it should be and then 10x it, then most of the problems would stop. But they won't. Okay. Alright, stream. I'm out later, guys.